Hello and welcome to Sleepy Science. Right now, you feel awake, aware, and fully inside your own mind. But consciousness is far less stable than it seems. Your attention can move before you notice it moved. Thoughts can appear without revealing where they came from. You can read, walk, listen, breathe, and perform familiar actions while only a fraction of what your brain is doing ever enters awareness. Concentration can make the surrounding world almost disappear. Fatigue can quietly break consciousness into unstable moments. General anesthesia can erase experience while the brain remains active. And even when you look directly into another person's eyes, you can never step inside the private world they are experiencing. These are not philosophical tricks or supernatural claims. They are real questions and phenomena studied in psychology, neuroscience, sleep research, and consciousness science. And the deeper scientists investigate them, the stranger the simple feeling of being awake begins to look. Tonight, you'll explore 60 discoveries and mysteries that reveal how consciousness appears, disappears, narrows, wanders, rebuilds itself, and somehow creates the feeling that there is a world happening from the inside. Before we begin, like the video and subscribe. Then get comfortable, let your attention settle, and notice something you normally never question. The fact that at this very moment, there is something it feels like to be you. You can be awake for hours without fully noticing your own thoughts. You can spend an entire afternoon thinking almost continuously and still have only a vague idea of what passed through your mind. This sounds contradictory because thoughts feel like the most private things you possess, yet consciousness does not automatically keep track of its own contents. During ordinary waking life, ideas, memories, worries, images, fragments of language, and predictions can appear and disappear so quickly that many of them are never examined as thoughts at all. They simply become the temporary background from which your next action emerges. Psychologists distinguish between having a thought and becoming aware that you are having it, a capacity often called meta-awareness. The difference becomes especially clear during mind wandering. You may be washing dishes, walking somewhere familiar, or staring through a window while an internal sequence unfolds about tomorrow. An old conversation, a hypothetical argument, or something you cannot even reconstruct afterward. At some point you suddenly notice, I was thinking about something else, but that realization is not the beginning of the thought stream. It is the moment you became aware of a process that had already been running. Experience sampling studies in which people are interrupted at unpredictable times and asked what was happening in their minds repeatedly show that waking thought often drifts away from the immediate environment. More interestingly, people are not always aware that this wandering is occurring while it is happening. Your brain can generate internal material without simultaneously producing a second layer of consciousness that labels each event as a thought I am now having. That would be inefficient. If every mental event demanded inspection, ordinary cognition could become crowded with commentary about commentary. Instead, the mind seems able to let many processes unfold quietly until something makes them relevant enough to notice. This is why introspection can be surprisingly difficult. The moment you ask yourself, what was I just thinking? You may find only fragments, because thoughts are not necessarily stored as a complete transcript. Some disappear as soon as attention changes. Others leave only an emotional residue, a sense of tension or anticipation, without a clear memory of the sentence or image that produced it. Researchers studying spontaneous thought have found that mental life varies along dimensions such as vividness, emotional tone, intentionality, and connection to current goals, suggesting that the stream inside you is far less uniform than the single word thinking implies. Sometimes you deliberately reason, sometimes a memory surfaces, sometimes language runs silently, sometimes there is only an impression too vague to put into words, and through much of it, you remain unquestionably awake. Your eyes are open, your body is functioning, and you can respond to the world. Yet awareness of your own mental activity may be incomplete. This creates a curious separation inside everyday consciousness. You are the place where thoughts happen, but you are not always watching them happen. Perhaps that is why becoming aware of a thought can feel almost like discovering something that was already in the room. The mind does not merely contain what you consciously inspect. Beneath the small portion you notice, it is continuously producing, associating, remembering, and anticipating. And every so often, awareness turns inward for a moment and catches one of those processes in motion, reminding you that being conscious does not mean seeing everything your own consciousness contains. Your awareness can shrink until almost everything else disappears. A crowded world can become astonishingly small when one thing suddenly matters more than everything around it. You may be searching desperately for a lost key, following a difficult instruction, threading a needle, playing the final seconds of a close game, or trying to recognize a face across a busy station. And for a short time, the rest of the scene seems to lose its weight. The room has not changed, the sounds have not stopped, and objects outside your focus are still sending information toward your senses. But your experience becomes narrower because attention is selective rather than evenly distributed across everything available to you. The brain receives far more sensory information than can be processed with equal depth, so it continuously allocates limited resources toward what seems most relevant to the current goal. When those resources become strongly concentrated, psychologists sometimes describe the result as attentional narrowing. Information near the center of your task can receive more detailed processing, while events outside it become easier to miss, even when they seem obvious in hindsight. Famous experiments on inattentional blindness demonstrate how dramatic this can be. When people are given a demanding visual task, they can fail to consciously notice an unexpected object passing directly through the scene. The eyes may face the event, yet seeing in the ordinary sense does not guarantee that the event becomes part of conscious experience. This effect is not evidence that vision shuts down outside a tiny spotlight. The brain continues processing many unattended features, and some especially important events can still break through. But awareness has priorities, and priority changes what reaches the foreground. Under high mental workload, stress, intense concentration, or strong goal pursuit, those priorities can become increasingly narrow. Pilots, drivers, athletes, surgeons, and even ordinary people searching for something can experience versions of this phenomenon, which is one reason training often emphasizes deliberately scanning the wider environment, rather than trusting that important information will automatically be noticed. Emotional states can narrow attention as well. A threatening object may dominate perception so strongly that surrounding details are remembered poorly, a pattern sometimes discussed in research on weapon focus during eyewitness situations. The same basic principle can appear in less dramatic settings. When you are deeply focused on a difficult sentence, the music in the room may recede. When you are watching for someone to arrive, unrelated faces become almost meaningless. When you are concentrating on pain, the rest of the body can seem temporarily distant. The striking part is how complete the world still feels while this is happening. You rarely experience a black void around the object of attention. Instead, consciousness gives you the impression of a stable surrounding world, even when much of it is represented only loosely and would be difficult to describe moments later. Your experience is therefore not a perfectly detailed copy of everything before you. It is a continuously prioritized construction, rich where attention is concentrated and far thinner elsewhere than intuition suggests. This can be useful because a mind that treated every sound, texture, movement, and object as equally important would quickly drown in information. But the same efficiency carries a quiet warning. What feels absent may simply be unattended, and what feels like the whole world may be only the small region your mind has decided matters right now. Awareness can narrow without walls closing around you, and when it does, reality itself seems to contract to fit the shape of your attention. A thought can enter consciousness without you knowing where it came from. Sometimes a sentence appears inside your mind already finished, as if someone placed it there while you were looking the other way. You are walking, showering, staring at a ceiling, or doing nothing especially demanding when an idea suddenly arrives. A person you have not thought about for years. The answer to a question you were not deliberately solving. An uncomfortable suspicion, a line of music, a plan, a memory, or simply a strange sentence that seems to have no obvious beginning. What makes this experience so revealing is that you usually become aware of the result without witnessing the work that produced it. Modern neuroscience gives us good reason to think that much of cognition happens through processes that never themselves become conscious. Your brain is constantly activating associations between memories, concepts, emotions, sensory cues, and current goals. One idea makes related ideas slightly easier to activate. A smell can quietly increase the accessibility of an old memory. A word heard several minutes earlier can influence what comes to mind now, and an unresolved problem can continue interacting with stored knowledge even when you are not deliberately rehearsing it. Eventually, one pattern becomes strong or relevant enough to enter conscious awareness, and because you did not experience the intermediate steps, it can feel as though the thought appeared from nowhere. Psychologists have demonstrated versions of this through priming experiments, where exposure to one piece of information changes how quickly or easily related information is processed later, sometimes without the person being able to identify the earlier influence. Memory retrieval works in a similarly distributed way. When you suddenly remember the name of an old teacher, there is no tiny librarian in your head consciously searching shelves until the correct file is found. Activity spreads through networks of related information until a particular memory becomes accessible enough to be experienced. The same principle helps explain spontaneous ideas. A thought may have a history even when consciousness has no access to that history. This is also why asking "why did I just think of that?" can produce such uncertainty. You can often invent a plausible explanation afterward, but the explanation may not reveal the actual chain of neural events that led to the thought. Your conscious mind receives many conclusions without receiving the full record of their construction. That does not mean the thoughts are foreign, mystical, or inserted by some outside force. They are products of your own nervous system, shaped by your history, surroundings, current state, and countless associations operating beyond introspection. Yet there is something quietly unsettling in realizing that ownership and authorship do not always feel the same. A thought can undeniably be yours while still surprising you. You may experience yourself as the thinker, but you do not personally supervise every process that produces what you think. Consciousness often encounters the finished sentence after the invisible machinery has already been at work, and perhaps that is why the mind can still surprise the person who has lived inside it for an entire lifetime. You rarely notice the exact moment your attention moves. Try to catch the precise instant your attention leaves one thing and lands on another, and you may discover that the moment itself keeps escaping you. You can be looking at a sentence, listening to a voice, or watching rain against a window, and then suddenly realize that something else has become the center of your experience. But identifying the exact boundary between before and after is surprisingly difficult. Attention is often described as though it were a spotlight that you consciously point around the world, yet the biological process is less like moving a lamp and more like continuously changing the priority of competing information. At any moment, objects, sounds, memories, goals, and expectations are all competing for stronger representation in the brain. Networks involving frontal and parietal regions help bias that competition according to what you are trying to do, while salient events can redirect processing through faster stimulus-driven systems. These shifts can unfold over fractions of a second, and conscious awareness does not necessarily receive a separate notification announcing that a transition has begun. Experiments using spatial cueing reveal this clearly. If a brief cue suggests that something important is about to appear in one location, people can respond more quickly to a target appearing there than to one appearing elsewhere, showing that processing has already been reallocated before they would normally describe themselves as having made a deliberate shift. Other shifts are pulled by the environment. A flicker at the edge of vision, an unexpected movement, or a suddenly meaningful object can gain priority before you formulate an intention to attend to it. Even voluntary attention is not experienced as a sequence of visible internal commands. You decide to search a shelf for a particular book, for example, but then your attention samples titles, shapes, and locations through a rapid series of selections whose individual transitions are largely hidden from introspection. There is also a brief cost to switching. When attention must disengage from one target and engage another, processing can temporarily become less efficient, particularly when tasks demand different rules or responses. Researchers studying task switching repeatedly find measurable delays and increases in error after a change, suggesting that the brain must reconfigure itself rather than simply teleporting an unchanged spotlight from one object to another. Yet subjectively, these transitions usually feel smooth. You experience one coherent stream rather than thousands of tiny reallocations of processing. That smoothness may be one of consciousness's most useful illusions. If every adjustment arrived as a separate event, leaving this sound, selecting that object, suppressing this distraction, enhancing that memory, your mental life might feel unbearably fragmented. Instead, the machinery performs the transition and gives you the destination. By the time you notice that your attention has changed, you are often already standing on the other side of the shift. And this raises a subtle question about the feeling of control. Perhaps attention is genuinely something you can guide, but guidance does not require witnessing every movement. Much like steering a ship without seeing every turn of the machinery below deck, you experience the direction of your mind while most of the transitions that create that direction remain beautifully, efficiently invisible. The world feels fully present, even though only a small part reaches your awareness. The room around you seems complete right now, yet if someone froze the scene and asked you to describe everything in it, the confidence of your experience would collapse surprisingly quickly. You have the powerful impression that the whole visual world is simply there at once. The objects beside you, the shapes near the edge of your vision, the arrangement of furniture, the tiny details of surfaces, the positions of things you are not currently examining. But conscious perception does not contain a perfectly detailed copy of all of that information. Your eyes receive enormous amounts of light, and the visual system processes many features simultaneously. Yet the highest resolution region of human vision is concentrated around the fovea, the small central portion of the retina you use when looking directly at something. Farther from the center, fine detail declines dramatically, even though your experience rarely feels like a sharp island surrounded by blur. The brain compensates by combining what is currently visible with expectations, memory, and rapid eye movements that repeatedly sample different parts of the scene. This creates an extraordinarily convincing sense of continuity. You do not usually experience the gaps because perception was never designed to give you a photographic inventory of reality. It was designed to provide enough useful information for effective behavior. One of the clearest demonstrations comes from change blindness. In experiments, surprisingly large alterations to a scene can go unnoticed when the change occurs during a brief interruption, an eye movement, or another visual disturbance. A building can lose a major feature, an object can change position, or even a person involved in an interaction can sometimes be replaced without immediate detection under carefully controlled conditions. The point is not that you see nothing. It is that the feeling of possessing the entire scene in conscious detail is richer than the information you can actually report. Your visual system extracts relationships, likely meanings, shapes, identities, and whatever is currently useful, while leaving many details available to be sampled when needed, rather than maintaining every feature in equally vivid awareness. This efficiency explains why the world can feel stable, even though your eyes move several times each second, and each new fixation changes which part of the image receives the clearest retinal representation. The brain stitches these moments into a seamless environment instead of presenting you with the raw sequence. That seamlessness is so convincing that you may mistake availability for awareness. Because you can look toward the lamp whenever you want, you feel as though you were already consciously representing every detail of the lamp before you looked. But often, you were carrying something more economical, a sense that the lamp was there, that the room remained structured, that the world would still be waiting if you turned your gaze toward it. There is something quietly profound in this arrangement. The richness of experience does not come from holding every piece of reality at once. It comes from a brain skilled at giving you exactly enough structure to feel surrounded by a complete world, while keeping most of the detail outside the narrow center of conscious access. You walk through what feels like an endlessly detailed reality, yet at every moment, consciousness may be holding only a carefully selected fraction of it. The miracle is not that so little reaches awareness. The miracle is how effortlessly that little becomes a world. Your mind constantly switches between the outside world and its own inner world. Without moving an inch, you can leave the room you are sitting in and return several seconds later. Nothing supernatural happens. Your eyes remain open, sounds continue arriving, and your body stays exactly where it was. But the center of mental life shifts from what is happening around you to something generated inside you. A memory, a plan, an imagined conversation, a question about the future, and then quietly shifts outward again. Neuroscience increasingly describes waking cognition not as a single mode, but as a changing balance among systems that support different kinds of processing. When you are closely engaged with a demanding external task, networks involved in selecting sensory information and maintaining goals become strongly recruited. During periods of internally directed thought, another set of interconnected regions, commonly associated with the default mode network, often becomes more involved. This network includes areas such as the medial prefrontal cortex and posterior cingulate cortex, and is frequently active during autobiographical memory, imagining future situations, thinking about other people, and constructing internally generated narratives. Calling it a simple daydreaming network would be misleading because it participates in several complex forms of thought, and the brain does not merely flip between two isolated systems like a light switch. Instead, activity changes dynamically, with different networks cooperating or competing depending on what the moment requires. A third collection of regions often associated with detecting important events, the salience network, appears to help coordinate transitions between internally and externally focused states. Although the exact mechanisms remain an active area of research, you can feel the result during the most ordinary moments. A sentence someone says may send you into a private memory. A thought about tomorrow may dominate for a while. Then a change in the environment brings the outside world back into prominence. At other times, an internal goal deliberately turns you outward. You stop imagining dinner because you need to find an address, answer a question, or examine something carefully. What is remarkable is how normal these transitions feel. You do not experience your mind as repeatedly rebuilding its orientation toward reality, yet the balance between inner and outer information is constantly changing. Neither side is merely a distraction from the other. Internal thought allows you to rehearse possibilities, reorganize memories, understand other people, and prepare for events that are not happening yet. External engagement keeps those private models anchored to what is actually occurring around you. Problems arise when the balance becomes poorly matched to the situation. When internal concerns dominate a task that requires close contact with the environment, or when constant external stimulation leaves almost no space for reflection. But under ordinary conditions, the movement itself is fundamental to human cognition. You are not a mind permanently pointed outward through the senses, nor are you a sealed inner world occasionally interrupted by reality. You live at the boundary between the two, continually borrowing information from what is present, and then retreating inward to interpret, remember, imagine, and predict. Perhaps that is why consciousness can feel both intimate and vast. One moment it is shaped by the room around you, and the next it contains a place that exists nowhere in that room at all. You can listen to someone while part of your mind is somewhere else. A person can be speaking directly to you, while only part of what they say ever becomes part of your inner world. You recognize their voice, follow enough of the conversation to nod at the right moments, and may even answer simple questions. Yet another stream of thought is quietly occupying you at the same time. A worry about tomorrow, something embarrassing that happened earlier, a decision you have not made, a memory triggered by a single phrase. This divided experience is possible because understanding speech is not one indivisible operation. Your auditory system first has to separate a voice from other sounds, track its changing frequencies and rhythm, identify speech sounds, group them into words, and connect those words into meaningful phrases. Much of that processing is highly practiced and can continue with relatively little deliberate effort, especially when the language and subject are familiar. But following the deeper meaning of a conversation requires more. You must maintain what was said a few moments ago, relate new statements to earlier ones, infer what the speaker intends, notice subtle changes in tone, and update your understanding as the conversation develops. Those higher-level operations compete for limited cognitive resources. If part of those resources becomes occupied by an internal concern, you may still process the surface structure of speech while constructing a much poorer representation of what the speaker actually means. Laboratory studies of divided attention and mind-wandering show that people can continue receiving language while later remembering less of its content, and the failure is often selective rather than total. You may retain a few important words, the emotional tone, or the general subject while losing the reasoning that connected one statement to the next. This helps explain a familiar social mystery. Sometimes you genuinely heard what someone said, and yet cannot answer a question about it seconds later. The sound entered the system, but the information was never stabilized strongly enough to become a useful memory. Conversation also gives you ways to hide this from yourself. Familiar social responses such as nodding, saying yeah, adjusting your expression, or producing short acknowledgements can occur with surprisingly little analysis of the speaker's full message. These signals help conversations flow, but they can create the appearance of complete engagement even when comprehension has become shallow. Then the speaker says something that demands a specific response, and the illusion collapses. You suddenly discover that you know the topic, but not the point, as if you had been standing beside a river and only now realized you had stopped following where the water was going. This does not mean that listening is normally fake, or that attention must be perfect for communication to work. Human conversation is resilient because language contains redundancy, context provides clues, and the brain can often reconstruct missing information. But there are limits to that reconstruction. A crucial qualification, a change in emotional tone, or a small detail can disappear if the relevant resources were elsewhere when it arrived. And this gives listening a deeper meaning than simply keeping your ears open. To truly follow another person, your brain must repeatedly give their words enough priority to connect them into something larger than sound. Perhaps that is why being listened to can feel so different from merely being heard. In both cases, your voice reaches another nervous system, but only in one does enough of that other person remain with you to let your meaning take shape. You can read an entire page and suddenly realize you absorbed almost nothing. The most unsettling thing about losing yourself on a page is that your eyes may reach the bottom before your mind notices anything went missing. You have moved through every line, recognized hundreds of words, perhaps even turned the page. Yet when you ask yourself what the passage actually said, there is almost nothing there. Reading can produce this strange illusion because recognizing written language and building understanding from it are different achievements. Your eyes do not glide smoothly across a sentence like a camera scanning a landscape. They make rapid jumps called saccades, separated by brief pauses called fixations. And during those pauses, the brain extracts useful information from the text. Skilled readers become extremely efficient at this process. Common words can be identified quickly. Familiar grammatical patterns are handled with little effort. and the eyes can continue moving through well-formed prose even when deeper comprehension has weakened. But understanding a page requires the brain to do something more ambitious than decoding individual words. It must construct what researchers sometimes call a situation model, an internal representation of what the text is actually describing. If a paragraph says that a scientist entered a laboratory, discovered an unexpected result, reconsidered an earlier assumption, and designed a second experiment, you do not normally remember 4 isolated sentences. You build a connected scene involving a person, a sequence of events, causes, goals, and changes in knowledge. That model must be continuously updated as new sentences arrive. When concentration weakens, word recognition may continue while this larger structure stops being built properly. The page therefore keeps moving without becoming a coherent idea. Eye-tracking research reveals another clue. When readers understand normally, their eyes frequently make small backward movements called regressions, returning to earlier words when something is difficult, ambiguous, or inconsistent. These movements are part of active comprehension. The brain notices that its interpretation is incomplete and seeks additional information. During episodes of mindless reading, that monitoring can become less effective. You may continue forward instead of repairing the missing meaning, allowing several sentences to accumulate on top of an increasingly empty foundation. Eventually, you encounter something that cannot be integrated. A reference to a person you do not remember, a conclusion whose argument you missed, or simply the end of the page, and only then does the failure become obvious. The experience also exposes an important distinction between familiarity and knowledge. Because each sentence looked understandable while you were passing through it, the whole page can feel as though it should be stored somewhere inside you. But comprehension is not produced by exposure alone. Meaning has to be assembled, connected to what you already know, and maintained long enough for the structure to survive beyond the immediate words. This is why slowing down, pausing to summarize, asking questions, or explaining an idea in your own words can transform reading. These behaviors force the brain to test whether a model actually exists instead of trusting the sensation of fluency. And perhaps that is the quiet lesson hidden in those blank pages you have technically read. Moving through information is not the same as possessing it. Your eyes can complete the journey while understanding remains near the beginning. And sometimes the only moment you truly start reading is the moment you realize you have to go back. You can be deep in thought without realizing you were thinking at all. One of the strangest journeys your mind takes is the one you notice only after you have already returned from it. You may be standing beneath a shower, walking along a familiar street, or staring absently at a cup when you suddenly discover that several minutes have been filled by an elaborate chain of ideas. And yet, while that chain was unfolding, you never explicitly noticed yourself thinking. This is more than simply being distracted. Conscious thought does not always arrive as a clear inner voice that announces each idea in sentences. Researchers studying spontaneous cognition find that mental activity can take many forms. Fragments of imagery, vague impressions, emotional themes, memories, imagined scenes, incomplete plans, and rapidly shifting associations that may never become fully verbal. You can therefore become immersed in an internally generated train of thought without continuously representing the fact that the train exists. The distinction becomes clearer when you notice how a thought sequence develops. A memory of a restaurant may activate the image of someone you met there. That person reminds you of a conversation. The conversation brings up a decision you regret. The regret leads to an imagined future in which you behave differently. Each transition makes sense while it is occurring because associative memory allows one mental state to make related material more accessible. But consciousness does not necessarily preserve a label explaining every transition. So when awareness finally turns toward the process itself, you may find yourself several conceptual steps away from where you began. Sometimes you cannot even reconstruct the route. You know you were absorbed, perhaps strongly enough that your emotional state changed, yet much of the sequence has already dissolved. Brain imaging studies of internally directed thought suggest that such moments recruit distributed systems involved in memory, imagination, personal meaning, and executive control rather than a single thinking center. This matters because it challenges the intuitive picture of thought as something a central conscious self deliberately manufactures. Much mental activity is generated through interacting systems whose intermediate operations are inaccessible to introspection. What eventually reaches you may be a scene, a conclusion, or simply the realization that your mind has been occupied. There is also a difference between being immersed in an experience and representing that experience to yourself. When you are deeply caught in a private scenario, your awareness may be directed toward the imagined argument or remembered place, rather than toward the fact that imagination itself is occurring. Only afterward does a second perspective emerge. You recognize that you had been lost in thought. That retrospective recognition can make the preceding minutes feel oddly ownerless, but they were not unconscious in the ordinary sense. There was experience there. What was missing was the reflective layer that says, "This is what my mind is doing right now." Perhaps this is why your inner life can be both intimately yours and surprisingly difficult to observe. You do not stand outside your thoughts watching them like objects moving past a window. Often, you are inside them, looking through them, inhabiting the little worlds they construct. And only when one of those worlds loosens its grip do you notice that, for a while, thinking was not something you were watching yourself do. It was simply where you were. Awareness can fade, gradually without a clear moment when it is gone. You can remember lying awake at night and remember waking the next morning, yet you almost never remember the precise instant between them when the world stopped being present. That missing boundary reveals something important about consciousness. It does not always disappear like a lamp being switched off. During the transition into ordinary sleep, awareness can become progressively less stable, less connected to the environment, and less organized before there is any obvious moment you could identify as the end. Sleep researchers divide this transition into measurable stages, but your subjective experience does not necessarily respect those neat boundaries. As drowsiness increases, responsiveness to the outside world weakens, thoughts may become less deliberate, and ordinary reasoning can begin to loosen. Images can arise without being intentionally imagined. Fragments of speech, faces, places, or impossible little scenes may appear and disappear in the state known as hypnagogia, the shifting territory between wakefulness and sleep. You may still know that you are lying in bed, then briefly become absorbed in something dreamlike, then return and wonder whether you had fallen asleep at all. Meanwhile, the brain is undergoing gradual changes. In early sleep, patterns associated with relaxed wakefulness give way to slower and more synchronized activity. Muscles relax further, and responses to ordinary sounds become less reliable. Yet none of this creates a clean subjective border, because recognizing the moment consciousness is fading would itself require enough consciousness to observe and remember that moment. There is a peculiar logical problem hidden here. The closer you come to losing stable awareness, the less capable you may become of recording the loss. Memory formation also changes around sleep onset, so the final moments of wakefulness may simply fail to become durable memories. This helps explain why you can insist that you never fell asleep during a short period, even when physiological recordings show that brief sleep occurred. Your personal timeline is built from what consciousness successfully preserves, and an unrecorded transition leaves no obvious marker behind. The same gradual quality can sometimes be felt when you are extremely drowsy while trying to remain awake. Thoughts become less connected. A sentence you are reading stops making sense. Time becomes difficult to estimate, and the boundary between something you intentionally imagined and something that simply appeared grows strangely uncertain. These are not signs that consciousness has one simple dimmer switch located somewhere in the brain. Rather, wakeful experience depends on many interacting processes: arousal, sensory responsiveness, memory, attention, and the ability to maintain a coherent model of what is happening, and those processes can change at different rates. This is why the disappearance of awareness can feel less like crossing a doorway and more like walking into fog. At first, the landscape is clear, then distant details soften. Connections become harder to follow. Eventually, there is no remembered landscape at all. And because there is no conscious observer standing outside the process to mark the final step, the exact instant of disappearance is usually missing from your story. You know there was a last waking moment. You simply cannot point to it, because by the time awareness was gone enough for the boundary to exist, there may no longer have been enough of you there to notice it. Your conscious mind can hold far less information than it feels like it can. Your mind feels spacious enough to contain an entire world, yet the part of it you can actively hold and manipulate at one moment is astonishingly small. Try keeping several unrelated pieces of information alive at once: a phone number, a name, a direction, a sentence you are composing, and something you must remember to do, and you can feel the system begin to strain. Psychologists call this limited workspace working memory, and modern research suggests that, under many conditions, conscious access may hold only a few meaningful units at a time, rather than the vast stream of information you seem to possess. The exact number depends on the task and on how information is organized. But the important point is that capacity is narrow. Your brain hides this limitation through a remarkably effective strategy called chunking. A sequence of letters that would overwhelm you individually can become manageable when recognized as a familiar word. 10 digits can become a few meaningful groups. A chess expert can remember complex positions better than a beginner when the pieces form familiar patterns, not because the expert has dramatically more mental storage, but because experience allows many separate details to be compressed into larger meaningful structures. Long-term memory performs another quiet trick. You do not need to keep everything consciously active because enormous amounts of information can remain outside immediate awareness until the right cue retrieves them. You know what your home looks like without simultaneously holding every room in consciousness. You know thousands of words without experiencing the entire vocabulary at once. Knowledge feels continuously available, and that availability can create the illusion that it is continuously present. But working memory is more like a small desk inside a vast library. The library may contain years of experience, yet only a few books can lie open on the desk at once. This limitation becomes obvious when you attempt mental arithmetic, follow complicated instructions, or listen to someone while trying to remember an unrelated message. New information begins pushing older information aside unless you rehearse it, organize it, or connect it to something already known. Stress, fatigue, and distraction can make this temporary workspace even less reliable, while expertise can make it seem larger by reducing how much space familiar operations require. And this narrow capacity is not simply a flaw. It may be part of what allows thought to remain organized. A consciousness flooded equally by every memory, sensation, goal, and possibility would not necessarily be wiser. It might be unable to choose anything at all. Your mind therefore works by exclusion as much as inclusion, holding a tiny collection of information in the foreground while depending on vast processes outside that foreground to supply what is needed next. The surprising truth is that your conscious mind may be small, not because the brain lacks information, but because coherent thought requires a narrow stage. What feels like an enormous mental world is supported by something much more modest. A few active pieces, continuously replaced, rearranged, and connected so smoothly that you rarely notice how little is actually under the spotlight at any one time. Paying attention to one thing can change the entire shape of your experience. Attention does not merely decide what you notice, it can change how strongly the same world is experienced. Focus closely on the ticking of a clock, and a sound that had seemed almost non-existent can become strangely prominent. Attend to a mild ache, and it may grow harder to ignore. Search for a particular color in a crowded street, and suddenly that color seems to appear everywhere. not because the environment has changed, but because the brain has changed the weight it gives to certain information. Neuroscience shows that attention can alter activity in sensory regions themselves. When you expect or deliberately attend to a location, feature, or sound, neural responses related to that information can become enhanced while competing signals are reduced. The brain is not simply receiving a finished version of reality and then choosing which part to think about. Selection begins during perception, shaping which signals gain strength, which relationships stand out, and which details become meaningful enough to enter experience. This can transform surprisingly basic qualities. In visual experiments, attended stimuli can sometimes appear higher in contrast or more distinct than unattended ones. In hearing, focusing on one frequency range or voice can improve the brain's representation of relevant acoustic information. Attention also interacts with pain. When people become absorbed in a demanding activity, painful stimulation can sometimes feel less intense, whereas sustained monitoring of bodily discomfort may amplify how intrusive it becomes. The physical signal has not necessarily changed. The conscious importance assigned to it has. Time can shift as well. Waiting anxiously for something while monitoring every second can make an interval feel long, while deep engagement in an absorbing activity can leave the same amount of clock time feeling compressed in retrospect. These effects reveal that experience is not determined solely by what strikes the senses. It is produced by an ongoing negotiation between incoming information and the priorities your brain places upon it. This is why two people can occupy the same room and inhabit psychologically different versions of it. One notices the music, another the temperature, another the tension in someone's voice, another the exits, another a tiny detail in a painting that everyone else passes without seeing. The environment supplies possibilities. Attention helps determine which of those possibilities acquire vividness. Yet attention is not infinitely powerful. You cannot simply decide that pain does not hurt or transform any perception at will. Its influence has limits, and many sensory processes continue regardless of what you choose. What matters is that awareness is not a neutral window through which reality enters unchanged. It has emphasis. It has foreground and background. It has priorities that can make one small element expand until it seems to organize the entire moment around itself. And once you notice this, an ordinary act of concentration becomes more mysterious. When you choose what deserves your attention, you are not only choosing what part of the world to examine, you are helping determine what kind of world for that moment you will actually experience. Many of your daily actions need almost no conscious supervision. By the time you reach for a door handle, part of the action may already be unfolding before you have formed anything resembling a deliberate instruction. Your hand turns to the correct angle, your fingers adjust their grip, your arm supplies roughly the needed force, and your body steps through the opening without requiring a running commentary about what each muscle should do. The same quiet efficiency appears throughout ordinary life. You pick up a familiar cup without calculating its shape, navigate through your home in dim light, position a toothbrush correctly, use cutlery, unlock a familiar door, or reach for a light switch in a room you know well. These actions are possible because repeated behavior can become organized into learned action patterns that are triggered by goals and environmental cues rather than assembled consciously from individual movements every time. Neuroscientists often describe this in terms of automaticity and habit learning, processes involving several interacting brain systems, including the basal ganglia and motor networks. Early in learning, an unfamiliar task demands much more conscious guidance because errors are common and the sequence has not yet been stabilized. With repetition, the brain becomes better at predicting what movement should follow another, what sensory feedback should be expected, and how much correction is required. Eventually, the conscious goal can remain very simple. Open the door, make the coffee, wash your hands, while much of the detailed execution unfolds without supervision. This is not the same as saying that your conscious mind becomes completely absent. It can intervene, change the goal, stop the action, or respond when the environment no longer matches expectations. But under normal conditions, constant supervision would be wasteful. Imagine having to consciously specify the position of every finger each time you buttoned a shirt, or decide separately which leg should move next while climbing stairs. Daily life would slow into an exhausting series of microscopic decisions. Automation solves that problem by allowing practice control systems to handle predictable details. It also explains why familiar environments can trigger behavior surprisingly strongly. You may enter the kitchen and begin reaching toward the place where a glass is usually kept, or unlock your phone and open a familiar app before remembering that you picked it up for another reason. The surrounding context can activate learned responses, because habits become linked not only to intentions, but to recurring cues. This is why changing a habit often requires changing the situation that triggers it, rather than relying on determination alone. Yet there is something deeper hidden inside this efficiency. You tend to think of yourself as consciously conducting your body from moment to moment, but much of ordinary competence depends on not doing that. The actions feel like yours because they are yours. They were learned through your experience, shaped by your goals, and remain available to conscious correction. But ownership does not require continuous supervision. In many of the most ordinary moments of your day, consciousness sets the destination and then allows trained systems to carry you through the details. What feels effortless is not simple at all. It is complexity that has been practiced until it no longer needs to introduce itself. A skill can become harder the moment you start thinking too much about it. The fastest way to make a familiar movement feel strangely unfamiliar can be to ask yourself exactly how you are doing it while you are doing it. A golfer who has repeated the same swing thousands of times may suddenly begin thinking about the angle of the wrist, the position of the elbow, the movement of the shoulder, and the timing of the hips. An emotion that normally unfolds smoothly starts to break apart. A pianist can stumble over a passage that was effortless a moment earlier after becoming intensely aware of individual fingers. An athlete under pressure can miss a routine action not because the skill vanished, but because conscious control began interfering with a system that had learned to operate without that level of instruction. Psychologists often discuss this phenomenon through ideas such as explicit monitoring or reinvestment. Once a highly practiced skill has become automated, deliberately bringing its individual components back under conscious control can disrupt their timing and coordination. Learning a complex movement usually begins in the opposite state. At first, you need instructions. A tennis serve may require conscious reminders about stance, grip, toss, and follow-through. With enough practice, however, those pieces become integrated into a coordinated motor pattern. The nervous system begins using rapid sensory feedback and prediction to make corrections too quickly and too continuously for conscious verbal reasoning to manage each one. The cerebellum is especially important for fine-tuning movement and predicting the sensory consequences of actions, while motor networks refine patterns through repetition. Once the skill is established, thinking "move this muscle now, then that one" is not an improvement. It can be like interrupting an orchestra to instruct every musician one note at a time. This is one reason performance can deteriorate under intense pressure. Anxiety increases self-monitoring. A player who normally acts fluidly begins checking the mechanics of the movement because the outcome suddenly feels important. The result can be the familiar phenomenon of choking under pressure. Although choking has several causes, and not every performance failure comes from overthinking, attention may also become consumed by worry, or arousal may simply become too high. But in skills that depend on well-practiced coordination, excessive conscious monitoring is a genuine risk. There is an important distinction here. Thinking is invaluable when you are learning, diagnosing a specific error, or deliberately changing technique. Coaches slow movements down precisely because conscious analysis can help rebuild a faulty pattern. The problem appears when that analytical mode is imposed at the wrong moment, particularly during execution of something already deeply learned. Expertise therefore creates an unusual paradox. You become better at a skill, partly by reaching a point where you no longer need to know consciously how every part is being produced. The knowledge has not disappeared. It has changed form. It lives in timing, prediction, calibration, and relationships between movements that may be difficult to translate back into language. This is why an expert can sometimes perform something brilliantly and then struggle to explain exactly how. And perhaps that is one of the stranger lessons of mastery. Conscious understanding can build a skill, but at a certain point, the skill must be allowed to become quieter than the mind that created it. Sometimes doing something well requires knowledge. Sometimes doing it exceptionally well requires knowing when to stop watching yourself do it. Your breathing exists on the strange border between automatic and conscious control. There is one rhythm inside you that can continue for an entire night without your permission. Yet the instant you think about it, you can take control. Your breathing occupies an unusual border in the nervous system because it must satisfy two very different demands at once. It has to operate automatically enough to keep you alive when you are asleep, distracted, or unconscious, but it also has to become voluntary when you speak, sing, hold your breath, blow out a candle, or deliberately slow yourself down. Most of the time, specialized networks in the brainstem generate and regulate the basic respiratory rhythm without requiring conscious supervision. These circuits continuously respond to information about the chemistry of your blood, especially changes related to carbon dioxide. When carbon dioxide rises, receptors in the body and brain help signal that ventilation should increase. When metabolic demand falls, breathing can become quieter. This automatic regulation is so reliable that you can spend hours never thinking about a single breath while your nervous system adjusts its depth and rate thousands of times. Yet breathing is unusual among vital processes because regions involved in voluntary movement can temporarily influence the same respiratory muscles. You can inhale deeply simply because you choose to. You can alter the timing of exhalation to produce speech. You can deliberately breathe slowly for a while, even though no external change forced you to do so. That dual access is why reading about breathing often produces an immediate and peculiar effect. The process that was running invisibly suddenly enters awareness, and for a few moments you may feel as though you must perform it yourself, but you do not need to remain in control. The moment your attention moves elsewhere, automatic regulation quietly resumes. Even breath holding demonstrates the limits of voluntary authority. You can suppress breathing temporarily, but as carbon dioxide accumulates, the urge to breathe becomes increasingly powerful. For most people, conscious intention cannot simply override the body's respiratory drive indefinitely. The automatic system waits beneath voluntary control, prepared to reclaim the task. This shared arrangement also helps explain why breathing has such a close relationship with emotional state. Fear, excitement, laughter, crying, pain, and relaxation can all alter respiration through networks connecting the brainstem with regions involved in emotion and arousal. Conversely, deliberately changing the pace of breathing can influence bodily arousal, although it is not a magical switch capable of controlling every emotion. Slow, comfortable breathing can alter signals traveling between the lungs, cardiovascular system, and brain, which is one reason breathing practices appear in relaxation techniques across many cultures. The deeper fascination, however, lies in how easily breathing crosses the boundary between what you do and what happens to you. Your heartbeat cannot normally be slowed by a simple command in the same direct way. Digestion does not pause because you decide to stop it. But breathing allows consciousness to reach downward into a function essential for survival. Touch it for a while, and then release it again. Every unnoticed breath reminds you that life does not require your constant attention, while every deliberate breath reveals that consciousness can sometimes enter the machinery and gently change its rhythm. You live on that border constantly, part organism, part observer, breathing without deciding, and then suddenly deciding to breathe. You can move from automatic behavior to full awareness in a single moment. Nothing reveals how much of life runs quietly in the background, like the instant something unexpected snaps you completely into the present. You may be walking a familiar route, washing dishes, fastening a jacket, or moving through some ordinary sequence with little sense of each individual movement when suddenly a glass begins to slip. Your foot lands strangely, an object is not where it should be, or the expected resistance of a door disappears. In that fraction of a moment, the entire quality of experience can change. What had been smooth and barely noticed becomes vivid, specific, and demanding. This transition happens because the nervous system is constantly comparing what it expects to happen with what actually arrives through the senses. When movements are familiar, the brain can generate predictions about their likely consequences. How heavy the cup should feel, where the next step should land, what sensation should follow when a drawer opens. As long as incoming feedback roughly matches those predictions, there is little reason to recruit intensive conscious monitoring, but a significant mismatch creates what researchers broadly describe as prediction error, evidence that the current model of the situation is no longer good enough. Unexpected information becomes more important because it may signal that behavior must change immediately. Networks involving the anterior cingulate cortex and other frontal regions are strongly associated with detecting conflict, errors, and situations that require adjustments in control. When the usual response stops working, these systems can help increase cognitive control, bringing the problem into sharper awareness and allowing behavior to become more flexible. You can feel this shift when you miss a stair you thought was there. For the preceding steps, walking required almost no conscious calculation. Then the expected surface fails to arrive, and suddenly body position, balance, and the environment become intensely relevant. The same principle appears in less dramatic situations. A familiar password fails, and you stop typing automatically and inspect each character. A key refuses to turn, and your grip becomes something you consciously notice. You hear an unusual sound from a machine you use every day, and an object that was almost invisible through familiarity suddenly becomes the center of the room. The transition can feel instantaneous because consciousness is especially useful when routine predictions are no longer sufficient. This does not mean every error must become conscious. The nervous system corrects countless tiny deviations without you ever noticing them. Your posture is adjusted, movements are refined, and small inaccuracies are repaired continuously below awareness. Full conscious involvement becomes more likely when the discrepancy is large, persistent, uncertain, or relevant to your goals. In this sense, awareness is not merely a permanent supervisor watching every action. It can function more like a flexible resource recruited when ordinary control needs help. That may explain why so many moments of sudden presence begin with surprise. Something breaks the expected pattern, and the familiar world becomes detailed again. You notice your hands. You notice the floor. You notice exactly what you are doing. The moment before felt almost transparent. The moment after feels unusually alive. And perhaps this is one reason consciousness is so closely tied to novelty. When everything proceeds as predicted, the brain can afford to remain economical. But when reality refuses to behave as expected, awareness steps forward, as though the mind has been quietly waiting for the moment when the familiar is no longer enough. Familiar routines can continue while your consciousness drifts somewhere else. You can arrive at the end of a familiar routine and realize that the person who consciously experienced most of it seemed to be somewhere entirely different. Perhaps you folded an entire basket of clothes while replaying an old conversation, showered while planning the next week, prepared the same breakfast you always make while imagining a future that has not happened, or walked through several familiar rooms while barely registering the movements that carried you there. What makes these moments fascinating is not simply that routine actions can become automatic, but that an organized sequence can continue while conscious experience becomes occupied by an entirely different stream. Repeated routines are gradually tied to stable cues. One step creates the situation that triggers the next. The empty mug prompts the reach toward the cupboard. The toothbrush in your hand leads naturally toward toothpaste. Arriving at a familiar corner prepares the turn you have taken hundreds of times before. Behavioral scientists sometimes describe habits in terms of learned associations between contexts and responses. And once those associations are strong, a sequence may require surprisingly little moment-to-moment deliberation. This allows the brain to solve two different problems at once. One set of processes remains sufficiently connected to the environment to maintain the familiar activity, while internally generated cognition can move toward memories, imagined futures, unresolved concerns, or completely unrelated ideas. Importantly, this does not mean the routine continues without any sensory guidance. Your movements still depend on feedback from vision, touch, balance, and body position, and significant changes can alter what you do. What becomes reduced is the need to consciously formulate each next step. Researchers studying habitual behavior have found that repetition in stable contexts can make responses increasingly likely to be triggered by the situation itself, sometimes even when a person's current intentions have changed. This is why you may find yourself beginning an old routine after deciding to do something differently, or discover that you have followed a familiar sequence farther than you intended. The routine has acquired momentum from its history. Meanwhile, consciousness can be engaged with material that has almost nothing to do with the hands, feet, or objects presently involved. The odd result is that your mental life can temporarily split by function without literally splitting into separate minds. Behavior remains coordinated with the present, while thought explores somewhere absent. Most of the time, this division is useful. It allows familiar activities to consume less mental effort and gives imagination, planning, and reflection room to operate during otherwise predictable moments. But it also reveals how misleading the feeling of continuous conscious authorship can be. You remember the thought you were having while making tea more clearly than the movements that actually made the tea, even though both belong to you. One part of your life was happening through learned interaction with the world. Another was unfolding in a private landscape with no physical location at all. And when the routine ends, the two streams seem to meet again. The cup is full. The clothes are folded. You have reached the familiar doorway. Only then do you notice how far consciousness had wandered, while the practice structure of your life quietly carried on without asking to be watched. Conscious control often appears only when something unexpected goes wrong. You may not discover how little conscious control a task was using until the exact moment the task stops working. A familiar website behaves differently. A sentence you are typing produces the wrong word. A machine gives an unfamiliar response, or a simple sequence suddenly reaches a point where the usual next step no longer solves the problem. In that instant, behavior that felt effortless becomes something you must examine. Cognitive science has long distinguished between processes that can run efficiently under familiar conditions and executive control systems that become especially important when habits compete. Rules change, or several possible responses must be evaluated. Frontal regions of the brain play a major role in this flexible control, particularly when you must inhibit an obvious response, keep a new rule active, or choose between competing actions. A classic demonstration comes from the Stroop task. If the word blue is printed in red ink and you are asked to name the ink color, reading the word is so practiced that it interferes with the less habitual task of reporting the color. You can still answer correctly, but doing so requires control precisely because the automatic response is now inappropriate. Everyday life contains quieter versions of the same conflict. You begin typing an old password after it has been changed, reach toward the wrong cupboard after reorganizing a kitchen, or follow an instruction that normally works until one unusual condition makes it fail. When conflicting information appears, the brain must do more than continue the strongest response. It has to detect that the current rule is inadequate and increase deliberate regulation. Studies of errors reveal another intriguing feature. After making a mistake, people often slow down on the next response, a phenomenon known as post-error slowing. The nervous system appears to become more cautious after evidence that its current strategy may be unreliable. Conscious experience often changes with it. Details that seemed irrelevant a moment earlier become important. You reread the instruction. You inspect the controls. You reconstruct what you just did. You begin asking questions that were unnecessary while everything was going smoothly. In this sense, conscious control is especially valuable not because it performs every ordinary action, but because it can reorganize behavior when ordinary rules stop being dependable. That flexibility carries a cost. Deliberate control is slower, mentally demanding, and vulnerable to overload, which is why the brain does not use maximum conscious supervision for every predictable event. Instead, it seems to reserve intensive control for situations involving novelty, conflict, uncertainty, or changing goals. This creates a revealing asymmetry in your experience. Success often feels effortless because the processes producing it remain quiet. Failure becomes vivid because failure demands investigation. You suddenly become aware of the rule you were following, the assumption you had made, and the sequence you had never needed to describe before. A mistake, then, is more than an interruption. It is sometimes the moment the hidden architecture of your own behavior becomes visible. When the world behaves as expected, you simply continue. When expectation and reality stop agreeing, consciousness is asked to do one of the things it may be best suited for: abandon the easy answer, hold several possibilities open, and decide what to do when the familiar path no longer tells you. You can catch yourself doing something before remembering why you started. Sometimes your body reaches the middle of an action before your mind catches up with the reason it began. You open a drawer and suddenly pause, already holding the handle, wondering what you came to get. You unlock your phone and stare at the screen for a second before remembering the message you intended to send. You stand beside a shelf with the strange certainty that there was a purpose behind getting there. But the purpose itself has briefly vanished. This experience reveals an important feature of prospective memory, the system that allows you to remember intentions that must be carried out in the future. Unlike ordinary memory, where you deliberately try to recall something from the past, prospective memory often requires an intention to remain available while your attention is occupied with something else. You decide that when you reach the kitchen, you will take your medication. When you see a colleague, you will mention a question, or when you finish one task, you will begin another. The intention can influence behavior even when you are not actively repeating it in consciousness. Environmental cues may begin releasing parts of the planned action before the full reason is consciously retrieved. A location, an object, or the completion of a previous step can push behavior in the intended direction, leaving you with the unusual experience of acting first and recovering the explanation moments later. Psychologists distinguish between event-based intentions, which are triggered by something that happens, and time-based intentions, which must be remembered at a particular time without an obvious external cue. Event-based intentions often benefit from the world itself acting as a reminder. Seeing the envelope reminds you to post it, or encountering the person reminds you of what you meant to say. But those cues are not perfect. If several goals are competing, if you are interrupted, or if the context changes unexpectedly, the purpose can become temporarily inaccessible, even though parts of the behavioral sequence have already begun. This is why you sometimes feel as though you have caught yourself in the act of obeying an instruction whose author you cannot immediately remember. The intention has not necessarily been erased. Access to it has become momentarily weak, often remaining in the same location or looking at the object that triggered the behavior allows the goal to return. At other times, walking back to the place where the intention was formed helps because memory is sensitive to context. Aspects of the surrounding environment can become linked with what you were planning. There is something quietly revealing here about the way purpose operates inside you. You tend to imagine intention as a sentence held steadily in consciousness until an action is completed, but real intentions can become dormant, reappear through cues, and guide fragments of behavior without remaining continuously present in awareness. You can begin moving toward a goal while temporarily losing the story of the goal itself. Then the reason returns, and the action suddenly feels coherent again. For a brief second before that happens, you glimpse an unusual truth. Knowing what you are doing and knowing why you are doing it are not always delivered to consciousness at exactly the same time. Your mind can return to a task before you realize it ever wandered away. The most invisible lapse of attention may be the one your brain repairs before you discover that anything went wrong. You are working through a familiar task when your thoughts quietly drift elsewhere. Yet a few moments later, you are processing the task normally again, with no dramatic realization that you had ever left it. Only occasionally does some missing detail expose the detour. Many other times, the departure and return may pass without becoming an event you can later report. Researchers studying mind wandering have found that attention can fluctuate on relatively short timescales, and people do not always possess continuous meta-awareness of those fluctuations. This means that the mental system responsible for performing a task and the system that allows you to notice the state of your own attention are not perfectly synchronized. Your focus can weaken, internally generated material can become more prominent, and then task-relevant processing can strengthen again before you consciously form the thought, "I was distracted." One reason is that tasks themselves continuously provide signals capable of re-engaging you. A new sentence appears, a visual element changes, a response becomes necessary, or the next step requires more information than can be supplied by momentum alone. These events increase the priority of external processing and can pull cognitive resources back toward the goal. Laboratory studies often detect attentional fluctuations through changes in reaction time, accuracy, eye behavior, or brain activity, even when participants do not report noticing every lapse. In other words, researchers can sometimes see evidence that performance briefly became less stable, even though the person experienced no clear subjective boundary between being focused, wandering, and focused again. This makes attention different from a simple switch with two obvious settings. It behaves more like a system whose strength rises and falls, sometimes enough to alter performance, but not enough to produce a memorable feeling of disengagement. Importantly, returning to a task does not require recovering every thought that occupied the interval. The brain can preserve the broader task set, the rule, goal, or context that tells you what you are doing, well enough to resume once relevant information becomes dominant again. You may therefore continue from the correct place without having to consciously reconstruct the entire task from the beginning. This is one reason brief fluctuations can remain hidden. If nothing important was missed, and the task still makes sense when attention returns, there may be no error demanding explanation, and therefore no reason for consciousness to mark the episode. What you remember later is a continuous period of work, even though the quality of engagement may have pulsed beneath that smooth memory. This does not mean attention is constantly failing, or that every unnoticed fluctuation matters. Human cognition is built to tolerate small variations, and many activities contain enough redundancy for brief reductions in focus to have little consequence. But the phenomenon changes the way you might think about concentration. You usually judge attention by whether you remember losing it, yet the absence of that memory does not prove perfect continuity. Sometimes the mind wanders and announces its return. Sometimes it comes back so quietly that there is no announcement at all. And in those moments, consciousness edits the transition out of its own story, leaving you with the impression of an unbroken journey across terrain. Your attention may actually have left and re-entered without ever telling you. Thinking about a simple action can suddenly make the action feel difficult. The moment you ask yourself exactly how you swallow, walk, blink, or position your tongue, an action that has worked flawlessly for years can suddenly feel awkward and strangely complicated. Nothing is wrong with your body. What has changed is the level at which you are trying to control it. Many simple movements are coordinated through fast sensorimotor processes that combine touch, muscle feedback, balance, prediction, and learn timing without translating every adjustment into conscious language. When you walk, for example, you do not normally calculate when each knee should bend or how far the foot should swing. Your nervous system continuously integrates information from muscles, joints, vision, and the inner ear, making tiny corrections faster than deliberate reasoning could comfortably manage. But if you suddenly turn your attention toward each component, where exactly is my foot landing? Am I moving my arms correctly? When should I shift my weight? You can interfere with the smooth organization of the movement by forcing normally integrated processes into a slower, more explicit form. Researchers studying movement control sometimes call this reinvestment. Knowledge that was previously used implicitly becomes consciously reapplied during performance. The effect is especially noticeable when a movement is familiar enough that its parts are rarely experienced separately. You can create a mild version right now by paying close attention to your tongue. A moment ago, you probably had no awareness of where it rested. Now its position may feel oddly important, perhaps even uncomfortable, despite nothing physically changing. The same can happen with blinking. Once you begin monitoring each blink, something previously effortless starts to feel as though you must decide when to do it. This does not mean conscious attention is harmful to movement in general. It is extremely useful when learning something new, recovering from injury, or deliberately correcting technique. The difficulty appears when consciousness tries to micromanage a process whose coordination depends on relationships too rapid and detailed to be conveniently represented as verbal instructions. There is also a psychological layer. The more you monitor whether an action feels normal, the more likely you are to notice tiny variations that would ordinarily be ignored. Those variations can then feel like evidence that something is wrong, causing even more monitoring and making the action feel increasingly unnatural. What changed was not necessarily the movement, but your relationship to it. A simple action became an object of inspection instead of something you were simply doing. And this reveals a curious limit of introspection. Understanding more about an action does not always give you better control over it in the moment. Sometimes the nervous system performs beautifully precisely because consciousness is not standing over every movement asking how it is being done. The strange difficulty begins when you take something your body knows as a whole and demand that your mind explain it piece by piece. Repetition can push an action out of awareness without making it less precise. Movement can become less noticeable to you at exactly the same time that your brain becomes better at performing it. At first, learning a new sequence feels crowded with corrections. Your fingers are too slow, your timing is uncertain, you must repeatedly check what comes next, and every mistake becomes obvious. Then repetition begins changing the nervous system. Connections involved in the movement are refined, unnecessary variation decreases, and the brain becomes better at predicting what sensory consequences should follow each action. Over time, the performance may require less activity from regions heavily involved in deliberate planning, while relying more efficiently on specialized motor and learning circuits, including the cerebellum, basal ganglia, and sensoromotor cortex. This process does not simply make an action faster, it can make it more consistent. Skilled typists, musicians, craftspeople, and athletes often execute repeated components with extremely reliable timing, while being unable to report the precise details of every movement they just made. Their lack of conscious access is not evidence that precision has disappeared. In many cases, it is a consequence of the system becoming more efficient. One reason is prediction. The cerebellum and related motor systems use internal models that estimate what should happen when a movement is made. If the result closely matches expectation, little correction is necessary. If there is a small mismatch, adjustments can occur rapidly without requiring the discrepancy to become a conscious problem. With practice, these predictions improve, allowing movements to be corrected through fast feedback loops that operate below the level of deliberate thought. Repetition also reduces uncertainty. A beginner faces many possible ways to perform the same action and must explore which ones work. An experienced performer has already narrowed that space through thousands of previous attempts, so the nervous system can reproduce a successful pattern with less conscious searching. This is why a pianist does not need to mentally locate every key during a familiar passage, and why someone who has used the same keyboard for years can strike letters accurately without being able to draw the keyboard from memory. Performance knowledge and descriptive knowledge are not identical. The body can retain highly precise relationships among timing, force, and position, even when consciousness contains only the larger goal. There is something almost paradoxical about mastery in this. Early learning feels vivid because every detail demands attention, while later expertise can feel quiet because those same details have been absorbed into more efficient control systems. You notice less, yet accomplish more accurately. Repetition has not erased the knowledge. It has moved much of that knowledge into a form that no longer needs to announce itself. And perhaps that is why true fluency often feels less like controlling every movement and more like discovering that the movement no longer needs to ask permission. An intention can stay active even when you are no longer thinking about it. You can decide to do something hours from now, forget about it completely, and still find that the right moment somehow brings the intention back. You tell yourself to give someone a message when they arrive, take something out of the oven after finishing another task, buy one specific item when you pass a shop, or send an email after a meeting ends. And then your conscious mind moves on to entirely different things. The intention is no longer sitting in the center of awareness, yet it has not necessarily vanished. Cognitive researchers describe this ability through prospective memory, but one particularly interesting feature is that an intention can remain in a kind of latent state, becoming accessible again when the environment provides the right cue. You do not need to continuously repeat, remember this for every future goal. Instead, when an intention is formed strongly enough, the brain can establish an association between the intended action and a future event. Seeing the person, reaching the shop, hearing the timer, or finishing the meeting can reactivate the goal even after a long period in which you were thinking about something completely unrelated. Experiments on prospective remembering suggest that sometimes people deliberately monitor the environment for these cues, but in other situations, retrieval can feel remarkably spontaneous. A relevant cue appears, and the intention suddenly returns to mind, almost as if the world itself reminded you. Researchers have proposed that the brain can maintain increased accessibility for information connected to unfinished goals, meaning that goal-related material may be easier to retrieve than completely irrelevant material, even when you are not consciously rehearsing it. This does not mean every forgotten intention is secretly being held somewhere in perfect form. Intentions decay, cues can be missed, competing goals interfere, and memory is notoriously fallible. What matters is that conscious rehearsal is not the only way a future plan can continue influencing cognition. There are also practical ways to strengthen this hidden persistence. An if-then plan, such as, when I put my keys on the table, I will take the medicine, links a specific environmental event to a specific response, making retrieval more likely when that event occurs. The intention becomes attached to a recognizable doorway in the future, rather than depending entirely on you remembering at the correct moment by force. This reveals something subtle about what it means to have a goal. A goal does not have to occupy your thoughts every second to remain part of the organization of your behavior. It can disappear from immediate awareness while still altering what certain cues mean to you. A ringing timer is just a sound to someone else. To you, it may suddenly reopen an intention that has been silent for 20 minutes. A familiar face appears, and a sentence you had completely stopped thinking about rises immediately into consciousness. For a moment, the future plan and the present world lock together. You may experience this as remembering, but beneath that simple word lies a remarkable capacity. The mind can plant instructions for a version of you who does not yet exist, then release them from awareness and trust that the right piece of reality may call them back. An intention, then, can be absent from thought without being entirely absent from you. One small mistake can suddenly pull an entire routine back into awareness. A single button fastened through the wrong hole can make you suddenly conscious of a sequence your hands had been performing almost invisibly. Until the mistake, getting dressed was not a collection of separate decisions. It was simply happening. Then something feels misaligned, the fabric sits incorrectly, and an action that had been flowing as one smooth unit suddenly breaks apart into visible pieces. Where did I go wrong? Which button belongs here? How far back do I need to undo this? This transformation reveals that familiar routines are often organized hierarchically rather than represented as long lists of isolated movements. The brain can treat several individual actions as one larger action unit, allowing you to think at the level of the goal. Button the shirt, wrap the package, enter the code, while the detailed sequence unfolds beneath it. Researchers studying action control describe behavior in terms of nested structures. Broad goals contain smaller sub-goals, and those sub-goals contain individual movements. As long as the sequence produces the expected intermediate results, there is little need for consciousness to inspect every layer. A small error, however, can destroy the usefulness of the larger chunk. If you type one wrong digit into a familiar code, the remaining finger sequence may suddenly become uncertain. If one shoelace loop forms incorrectly, movements that usually follow naturally may need to be reconstructed. If you skip one ingredient in a familiar recipe and notice the texture is wrong, you may mentally replay several previous steps to locate where the sequence diverged. The mistake does something psychologically important. It forces you to unpack what had been compressed. Actions that normally exist as a single fluent unit become separate again, because the brain must identify the location of the failure. This is one reason errors can make familiar procedures feel momentarily unfamiliar. You know how to perform the routine, but correcting it requires access to a level of detail you normally have no reason to represent consciously. The effect is especially revealing in serial actions, where each completed step creates the conditions for the next. If one step is omitted or performed in the wrong order, later movements may no longer fit the state of the world, and the mismatch exposes the hidden structure of the sequence. You suddenly notice that what felt like one action was actually a carefully ordered architecture of smaller ones. There is an almost philosophical lesson hidden inside these tiny mistakes. Fluency conceals complexity. When everything works, the mind experiences the result rather than the machinery. You do not feel each rule that makes the routine possible, because successful coordination hides its own construction. But one misplaced movement can tear open that smooth surface and reveal the layers underneath. For a few seconds, you become conscious not merely of what you are doing, but of how many invisible decisions had been folded into the action. Then you fix the error, the sequence reconnects, and the details begin fading again. The routine becomes simple once more. Not because it ever was simple, but because your brain has restored the structure that allows complexity to disappear. You can watch your own thoughts arrive without feeling like you summoned them. Sit quietly enough, and you may catch something remarkable. A thought can appear in your awareness before you experience any decision to create it. A phrase surfaces, an image flashes, a memory opens, or a worry suddenly announces itself, and instead of immediately following it, you simply notice that it has arrived. This experience becomes especially clear during practices that ask you to observe mental events without deliberately directing them. You may decide to watch the breath, for example, and within seconds discover that the mind has produced plans, judgments, memories, fragments of music, or completely unrelated ideas without first asking permission. Neuroscience does not suggest that these thoughts come from nowhere. They arise from ongoing activity distributed across many systems involved in memory, emotion, language, prediction, and association. What is unusual is that the processes constructing them are largely unavailable to introspection. You can observe the product once it becomes conscious, but you cannot normally watch the neurons searching memory, activating related concepts, comparing possibilities, and assembling the material that will eventually appear. This creates a striking difference between initiating a mental goal and controlling every mental event that follows from it. You can deliberately decide to solve a problem or remember a birthday, but you cannot simply choose the exact next association that will enter awareness. Try it. Decide to think freely for 30 seconds while predicting every thought before it occurs. The task contains a contradiction. If you already know exactly what the next thought will be, then, in an important sense, it is already present. Psychological research on spontaneous thought supports the idea that much of mental content emerges without deliberate initiation. And studies of meditation have made this especially useful to investigate because trained participants can become better at recognizing thoughts as events rather than automatically identifying with their content. Brain imaging does not reveal a tiny generator pressing a button for each idea. Instead, spontaneous cognition appears to depend on interactions among large-scale networks involved in internally generated thought and cognitive control. Sometimes a thought is allowed to develop. Sometimes it is rejected. Sometimes attention becomes captured by it before you recognize what happened. But with enough observation, you can experience a curious separation between the appearance of a thought and your response to it. An angry idea can arise without requiring you to act angrily. A frightening possibility can appear without becoming a prediction. An absurd image can pass through awareness without revealing some hidden truth about who you are. This distinction is psychologically important because people often treat the arrival of a thought as though it were a deliberate statement from the self. If I thought it, I must believe it. Yet the mind generates possibilities far more freely than that. Conscious control may have greater influence over what you sustain, examine, reject, or act upon than over which fragment happens to knock first on the door. And when you begin watching thoughts in this way, something subtle changes. You are no longer only inside the sentence, you are also aware of the sentence appearing. For a few quiet seconds, the mind becomes both the place where the thought emerges and the place where its arrival is witnessed. You did not necessarily summon the visitor, but you can still decide whether to invite it to stay. The thought in your awareness right now was completely absent a moment ago. Whatever is filling your mind at this exact moment had to become conscious somehow, because only seconds ago something else occupied its place. That transition is so ordinary that you almost never question it. One moment you are considering a voice, a memory, an image, or the meaning of this sentence. Then another mental content takes center stage, and the previous one recedes. Neuroscience still does not have a universally accepted explanation for precisely how any particular piece of information becomes conscious, but several influential theories begin from a similar observation. The brain contains far more ongoing processing than can be simultaneously available as a unified conscious experience. Different sensory signals, memories, goals, emotional reactions, and interpretations are active at once, yet only a limited subset becomes broadly accessible enough to influence reasoning, report, and deliberate action. Global workspace theories, for example, propose that information becomes conscious when it gains sufficiently widespread access across brain systems rather than remaining confined to specialized local processing. Other theories describe consciousness differently, and scientists continue debating the details, but experiments consistently show that information can be processed to some extent before a person reports consciously seeing, hearing, or recognizing it. In studies of visual awareness, a stimulus can be presented so briefly or masked so effectively that participants deny consciously seeing it, while subtle effects on later responses suggest that some processing still occurred. When conditions change and the stimulus becomes reportable, neural activity tends to become more widespread and sustained. This does not prove that consciousness switches on at one magical instant, nor does it mean that every thought arrives through exactly the same mechanism. It does reveal that conscious presence is the endpoint of competition and integration occurring before you experience the result. Consider what this means for an ordinary idea. A moment ago, the concept now occupying your mind may have existed only as weak activity among related memories, language systems, or current goals. Then something strengthened it. A word you heard, an association, a question, an emotional connection. and suddenly it became the content around which experience was organized. Once present, it can feel strangely inevitable, as though it had been waiting there all along. But consciousness has a short horizon. The thought that feels completely immediate now can fade within seconds and become difficult to reconstruct, replaced by another that feels equally central. Your inner life, therefore, has a continuous quality without containing a fixed set of contents. It is more like an ever-changing foreground produced from a much larger field of possible information. This may explain why trying to locate the beginning of a thought is so difficult. By the time you consciously encounter it, the processes that prepared it are already partly behind you, while the next potential contents are already being shaped beyond the edge of awareness. And there is something quietly astonishing in that. Your conscious world feels stable enough for you to call it me, yet its contents are perpetually arriving and leaving. The thought you are holding now was once absent. In another moment, it may be absent again. What remains continuous is not any particular idea, but the strange capacity for something that was nowhere in your experience to suddenly become, for a brief interval, the most immediate thing you know. You can notice a feeling before you can explain what the feeling actually is. Sometimes your body seems to know that something has changed before your mind can find the words for it. You may enter a room and feel uneasy without immediately knowing why. Receive a message and notice a heaviness in your chest before deciding whether you are disappointed or afraid. Or sit beside someone you care about and sense that something inside you has shifted, even though no clear emotion has yet taken shape. This happens because emotional experience is built from several processes that do not necessarily reach consciousness at the same time. Your brain is continually receiving signals from inside the body, changes in heart rate, breathing, muscle tension, temperature, the stomach, and other internal organs through a system known as interoception. Regions, including the insula, help integrate these bodily signals with information about your surroundings, memories, and expectations, contributing to the feeling of what is happening inside you. But recognizing that your state has changed is not the same as knowing exactly what that state means. Emotional labeling requires additional interpretation. The same racing heart might accompany fear before an exam, excitement before seeing someone you love, anger during an argument, or simple physical exertion. The bodily signal alone does not carry a perfect label saying, "This is anxiety," or "This is joy." Your brain must interpret it in context. That is why a feeling can arrive first as something vague. Tightness, restlessness, warmth, pressure, a sense that something is wrong, or an inexplicable urge to move away. Only seconds later may language and memory organize that raw experience into something recognizable. Psychologists sometimes distinguish between affect, the more basic qualities of feeling good or bad, activated or calm, and fully differentiated emotions such as guilt, jealousy, relief, or grief. Those richer emotions often require an understanding of the situation and what it means for you. You might therefore know that you feel bad before understanding that the feeling is embarrassment, or sense an unexpected lightness before realizing that what you are experiencing is relief. People also differ greatly in how easily they can identify and describe internal states. Some are highly sensitive to subtle bodily changes, while others find emotions difficult to name even when they can clearly tell that something is happening. This is one reason emotional awareness can improve when people pause long enough to ask not only, "What am I thinking?" but "What is my body doing and what happened just before this changed?" The goal is not to treat every bodily sensation as a secret message. A tense stomach can come from hunger, illness, caffeine, stress, or many other causes. The important lesson is that conscious explanation often arrives after the first wave of experience. You can feel the weather changing inside yourself before you know what kind of storm it is, and perhaps that is why emotions can sometimes seem mysterious, even to the person having them. You are not always given the meaning first. Sometimes consciousness receives the signal, sits with its unfamiliar weight for a moment, and only afterward discovers the name. You can know that you are confused before you know what confused you. Confusion has a peculiar talent. It can announce its presence before it tells you what caused it. You are following an explanation, watching a demonstration, reading an argument, or learning a new rule when suddenly something feels wrong. You may not yet be able to point to the sentence, assumption, or missing connection that created the problem, but you already know that understanding has broken somewhere. This ability is part of metacognition, the brain's capacity to monitor the quality of its own processing. Comprehension is not merely the passive accumulation of information. As you learn, the brain continuously compares new material with expectations and with the mental model you have already constructed. When a new statement fits, processing tends to feel fluent. When it conflicts with what came before, introduces an unexplained relationship, or exceeds what you can integrate, that fluency can suddenly drop. The important part is that the system can detect the drop before conscious reasoning identifies its source. Researchers studying learning often describe experiences such as judgments of confidence, feelings of knowing, and uncertainty as metacognitive signals. These signals are imperfect, but they allow you to sense that your understanding is weak without yet possessing the answer to why. Consider a simple instruction containing a hidden contradiction. You may reach the end and immediately feel that it does not make sense, even though it takes several seconds to reread the steps and discover that two of them cannot both be true. The initial feeling of confusion is not the explanation. It is the warning that the current representation has become unstable. Brain systems involved in detecting conflict and monitoring errors, including parts of the anterior cingulate cortex and prefrontal cortex, are often recruited when competing interpretations or responses are present. But confusion also emerges in learning when information creates what psychologists call an impasse. The strategy that was working no longer produces progress, yet the alternative has not been discovered. This can feel frustrating, but it is not always a sign of failure. In the right amount, confusion can be productive because it signals that your current model needs revision. Studies of education suggest that resolving manageable confusion can encourage deeper processing, particularly when learners are motivated and receive enough guidance to work through the inconsistency. Too much unresolved confusion, however, can become discouraging and lead to disengagement. This means the feeling has a useful role. It tells you that something requires attention before it tells you what that something is. You can respond by slowing down, separating assumptions, checking earlier steps, or asking yourself exactly where the argument stopped feeling coherent. Sometimes the source is a missing fact. Sometimes two concepts have been accidentally blended together. Sometimes the explanation itself is poor. And occasionally, your original understanding was wrong. So the confusion is the first sign that your mental model is beginning to change. There is something quietly sophisticated about being able to know that you do not understand. The mind does not need to possess the solution in order to detect the shape of a problem. Before clarity arrives, confusion can stand at the edge of awareness like a small internal signal saying, somewhere in what you believe, the pieces have stopped fitting. You can be conscious of the fact that you do not know something. There is a strange kind of knowledge hidden inside the sentence, I don't know. Somehow, your mind can recognize the shape of an answer that it does not possess. You may be asked the capital of an unfamiliar country, the name of a person you have never met, or how a machine works. And instead of producing a wrong answer, consciousness can arrive at something more sophisticated, the recognition that the required information is missing. This ability is part of metacognition, the capacity to evaluate your own knowledge rather than merely use it. To do this, the brain does not need to search every memory it has and prove that the answer exists nowhere. Instead, it can estimate whether the information available is strong enough, familiar enough, or connected enough to justify a response. Researchers study this through judgments of knowing and confidence. When people answer questions, they can often distinguish between information they know well, information they only suspect, and information they believe they do not know at all. These judgments are imperfect, but they reveal that cognition contains an internal monitoring system capable of evaluating its own limits. One clue comes from the difference between complete unfamiliarity and the famous tip-of-the-tongue experience. If someone asks you a question about a subject you have never encountered, you may immediately know that you lack the answer. But if you temporarily cannot retrieve a familiar name, the experience is entirely different. You may know the first letter, remember where you encountered the person, or feel strongly that the missing word is recoverable. In both situations, the answer is absent from consciousness, yet your mind represents the absence differently. This suggests that not knowing is not an empty state. It can contain information about how likely knowledge is to exist, how accessible it feels, and whether further searching is worth the effort. That distinction matters far beyond trivia. Good reasoning depends on recognizing where certainty ends. A person who can say, "I do not have enough information," is doing something cognitively different from a person who confidently fills the gap with a guess. Humans are vulnerable to overconfidence, of course, and we sometimes believe we understand things far better than we do. Psychologists have demonstrated this with the illusion of explanatory depth. People often report understanding familiar objects or processes until they are asked to explain them step by step, at which point the holes become obvious. Your sense of knowledge is therefore fallible, but the capacity to inspect it remains extraordinary. You can turn awareness toward your own mental inventory and discover not an answer, but a boundary. And perhaps that boundary is one of the most intelligent things consciousness can represent. Knowledge tells you what you can use. Recognized ignorance tells you where to look, what to ask, and when not to trust the first story your mind invents. You do not need to know everything to think clearly. Sometimes clarity begins at the exact point where you can see, with surprising precision, that something inside you is still missing. Your mind can detect its own uncertainty. Before you say, "I'm not sure," your brain may already be treating the decision differently. Imagine choosing between two nearly identical images, deciding whether a distant shape is a person or a tree, or answering a question when two possibilities both seem plausible. You eventually give one answer, but the answer arrives with a feeling attached to it. Strong confidence, mild hesitation, or something in between. That feeling of certainty is not simply decoration added after a decision. Research on metacognition suggests that the brain continuously evaluates the strength and consistency of the information supporting its choices. When evidence strongly favors one interpretation, decisions tend to be faster and confidence higher. When evidence is weak, noisy, or divided between alternatives, response is often slow and subjective confidence falls. Importantly, uncertainty is not the same thing as confusion. You can understand a problem perfectly and still be uncertain because the available evidence does not clearly support one conclusion. A doctor may understand two possible diagnoses, but lack enough evidence to distinguish them. A witness may clearly remember seeing a vehicle, but be uncertain about its color. The mind can represent that incomplete confidence, even when it cannot remove the uncertainty itself. Experiments show that people can often estimate the reliability of their own perceptual decisions, and brain regions in the prefrontal cortex have been associated with these metacognitive evaluations. Researchers sometimes compare objective accuracy with reported confidence to measure metacognitive sensitivity, how well a person's confidence distinguishes their correct decisions from their incorrect ones. Two people can perform equally well on a task, yet differ in how accurately they know when they are likely to be wrong. This means uncertainty monitoring is a skill separate from simply producing answers. Your brain can also continue evaluating a choice after you have made it. You may answer quickly, then experience a small internal hesitation that makes you check again. Evidence gathered immediately after a decision can sometimes alter confidence even when the original response remains unchanged. The system is therefore not merely asking, which option wins? It is also estimating, how much should I trust this result? That second question is essential because the world rarely provides perfect information. Vision is noisy. Memory is incomplete. Other people are unpredictable. The future is uncertain by definition. A mind that treated every conclusion as equally reliable would constantly make rigid decisions from weak evidence. Confidence allows behavior to remain flexible. Low certainty can encourage further checking, seeking advice, delaying commitment, or gathering more information. Yet confidence can also be misleading. Familiarity, emotion, repetition, and social pressure can make an idea feel more certain without making it more accurate. The feeling of certainty is therefore evidence about your internal processing, not a guarantee about the external world. And that distinction may be one of the most important lessons your own mind can teach you. You do not merely produce beliefs. You also carry a quiet estimate of how firmly those beliefs deserve to be held. Somewhere between knowing and guessing, consciousness can sense the unstable ground beneath its own conclusions, and sometimes wisdom begins by noticing that tremor. Trying to observe a thought can change the thought you were trying to observe. The instant you turn toward a thought to examine it, you are no longer experiencing exactly the same mental event that existed a moment before. A worry that was vague can become a sentence. An image that flickered briefly can sharpen because you are holding it in attention. A half-formed idea can acquire language, structure, and meaning simply because you ask yourself what you are thinking. This makes introspection fundamentally different from looking at a stone on a table. The stone can remain where it is while you study it, but a thought is an active process inside the same system doing the studying. Attention changes which neural representations remain active, which associations are strengthened, and which details are selected for further processing. When you mentally label an experience, I am angry, I am remembering, I am worrying, you have already added something that was not necessarily part of the original state, a concept about the state itself. Research on affect labeling illustrates this principle particularly well. Putting feelings into words can alter patterns of brain activity associated with emotional processing, meaning that describing an experience is not always a neutral recording of it. Similar problems appear whenever people are asked to report exactly what was happening in their minds. The act of preparing a report can organize something that may originally have been fragmented, non-verbal, or rapidly changing. This does not make introspection useless. It simply means that introspection is participatory. Think of a fleeting memory that appears unexpectedly. If you let it pass, it might disappear in seconds. If instead you stop and examine it, you may retrieve additional details, connect it with other memories, reinterpret its meaning, and strengthen your later memory of having remembered it. The object of observation has developed because observation became another event inside the same mental system. This is one reason researchers are cautious when treating verbal reports as perfect recordings of consciousness. People can sincerely describe what they experienced while still reconstructing parts of that experience during the act of describing it. Your mind does not contain a hidden transcript waiting to be read without disturbance. It contains processes that continue evolving while you inspect them. There is a quiet paradox here. Self-awareness gives you extraordinary access to your inner life, yet the closer you look, the more you participate in what you are trying to see. You can notice a thought, study it, name it, and question it. But you cannot completely step outside your own mind and observe it from nowhere. The observer is made of the same machinery as the observed. So when you ask, what exactly was I thinking? The answer may be partly discovery and partly creation. The original thought meeting the new thought that has arrived to look at it. The more closely you monitor yourself, the less natural your behavior can feel. You can be speaking perfectly normally until one small question enters your mind. Do I look awkward right now? Suddenly your hands seem too visible, your voice sounds unfamiliar, you become aware of where your eyes are pointing, and actions that felt effortless seconds earlier begin to feel staged. This is a form of heightened self-focused attention, and it can change social experience even when nothing obvious has changed to the people around you. Normally, conversation depends on rapid coordination among many processes, choosing words, reading another person's expression, adjusting tone, timing pauses, interpreting meaning, without requiring you to consciously evaluate yourself after every gesture. But when attention turns strongly inward, part of your limited processing capacity becomes occupied with monitoring your own performance. You begin constructing an imagined outside view of yourself. How am I standing? Was that laugh strange? Did I pause too long? What do they think I look like? Psychological research on social anxiety has shown that excessive self-focused attention can intensify discomfort, partly because people begin relying on these internal impressions as evidence of how they appear to others. A racing heart may become, "They can tell I'm nervous." A momentary difficulty finding a word becomes, "I sound incompetent." Yet other people may notice far less than you assume. This relates to what researchers call the spotlight effect. People tend to overestimate how much others notice their appearance, mistakes, and behavior because their own experience of themselves is so prominent. Self-monitoring can therefore create a feedback loop. You become concerned about appearing unnatural, so you supervise yourself more closely. The increased supervision makes the interaction feel less spontaneous. That awkward internal feeling then seems to confirm that something is wrong. Importantly, some self-monitoring is useful. Social life requires sensitivity to context, and noticing when you are interrupting someone or speaking too loudly can improve communication. The problem is not awareness itself, but the degree and target of it. When your attention becomes dominated by the image of yourself performing, less attention remains for the person, idea, or situation you were originally engaging with. The conversation stops feeling like something you are participating in and begins feeling like something you are watching yourself perform. This can happen during public speaking, first dates, interviews, photographs, or even while walking into a room where you suddenly feel observed. And it reveals something surprisingly fragile about natural behavior. Spontaneity often depends on not continuously checking whether you are being spontaneous. The version of you that feels most effortless may appear when attention is allowed to rest on the world, rather than constantly turning back toward the person who is experiencing it. Sometimes you become most like yourself precisely when you stop asking how successfully you are being yourself. Self-consciousness can make you feel like both the observer and the observed. There are moments when you stop simply being yourself and begin watching yourself be yourself. You walk into a room full of strangers, hear your own voice while speaking, catch your reflection during a conversation, or suddenly become aware that someone important is looking at you, and your experience seems to split into two perspectives at once. One part of you continues acting, while another begins evaluating the person who is acting. How do I look from there? What does my expression reveal? What impression am I creating? Psychology often describes this shift through self-focused or objective self-awareness. The ability to make yourself an object of your own attention. Human beings can represent not only the surrounding world, but also themselves as entities within that world. And this allows you to compare your behavior with standards, goals, social expectations, and imagined judgments from other people. Brain regions along the medial prefrontal cortex are frequently involved when people think about themselves, while systems involved in perspective taking help you estimate what another person might know, believe, or think about you. These processes can combine into something surprisingly vivid. You do not literally leave your body, yet you construct a model of yourself from the outside and temporarily experience that model alongside your first-person perspective. A camera can intensify the effect. So can a mirror, an audience, an interview, or simply noticing that someone is paying close attention to you. Researchers have found that mirrors and other self-relevant cues can increase awareness of discrepancies between current behavior and personal standards, which is why looking at yourself can sometimes make mistakes. Appearance or emotional reactions suddenly feel more significant. But self-consciousness is not inherently negative. The capacity to observe yourself is essential for reflection, moral evaluation, learning, and social adjustment. Without some ability to imagine yourself from another perspective, apologizing sincerely, recognizing inappropriate behavior, or understanding how your actions affect others, would become far more difficult. The strange part begins when this second perspective becomes so prominent that the ordinary first-person experience feels crowded. You are no longer only telling the story, you are imagining how you look while telling it. You are not merely laughing. You hear your own laugh as though it belongs to someone across the room. You are not simply standing. Posture becomes something to inspect. Consciousness has effectively built a temporary representation of itself and placed that representation back inside its own field of awareness. This is why intense self-consciousness can feel almost theatrical. There is the person performing and the invisible audience inside the same mind evaluating the performance. Yet neither perspective is a complete picture of you. The internal observer does not possess some perfectly objective camera angle. It is shaped by memory, expectations, insecurity, social knowledge, and assumptions about what other people notice. What feels like seeing yourself as others see you is actually your brain estimating how you might appear from outside. And that distinction matters because the imagined observer can be harsher, more attentive, or simply more inaccurate than any real person in the room. Still, the basic ability is extraordinary. Consciousness can turn itself into its own object without ever leaving itself. You can be the eyes looking outward and, almost simultaneously, the person those imagined eyes are looking at. For a moment, the boundary between subject and object folds inward, and you discover one of the stranger capacities of the human mind. You do not only experience being someone, you can experience yourself as someone being experienced. You can temporarily lose awareness of yourself when you become completely absorbed. Sometimes the clearest sign that you are deeply engaged in something is that, for a while, you almost disappeared from your own experience. You may spend an hour repairing something delicate, solving a complicated puzzle, drawing, building, exploring an unfamiliar idea, or following an activity that demands just the right amount of involvement, and afterward realize that you hardly thought about yourself during any of it. You did not repeatedly notice your posture, your identity, your plans for later, the passage of time, or the fact that you were a person having an experience. Awareness was still present. You were perceiving, deciding, correcting, and responding. But the usual sense of me occupying the center of every moment became quieter. Psychologists use the term absorption for states in which attention becomes deeply engaged with an experience, and studies of consciousness suggest that self-awareness is not a fixed ingredient that must remain equally prominent whenever you are awake. The brain continually constructs information related to the self. Memories about your past, evaluations of your current state, thoughts about how you compare with others, plans involving your future, and the ongoing narrative that connects these things into a personal identity. Much of this self-referential processing is associated with regions commonly grouped within the default mode network, although no single network simply creates the self. During demanding engagement with an activity, patterns of brain activity can shift away from some forms of internally focused, self-referential processing towards systems more directly involved in the task. Subjectively, this can feel less like losing consciousness and more like losing the need to keep mentioning yourself inside consciousness. Your hands still belong to you. Your memories have not disappeared. You would respond if someone called you, yet the continuous commentary about who you are and how you are doing can recede because it is not currently useful. This distinction is important because temporary reduction in self-awareness during healthy absorption is not the same thing as depersonalization, dissociation, or a loss of identity. In those conditions, altered self-experience can be distressing and involuntary. Ordinary absorption is usually the opposite. The self becomes less noticeable because engagement with something else has become more compelling. Time can also become harder to track, partly because monitoring time requires attention that may instead be devoted to the activity. Bodily signals that would normally enter awareness can remain in the background until they become strong enough to matter, which is why you might only notice thirst, stiffness, or hunger after the period of absorption ends. Then something breaks the state, a pause, a finished step, someone entering the room, and the self seems to return. you notice your body again. You remember the rest of the day. The wider context of your life reappears around the activity. It can feel as though you have come back from somewhere, even though you never physically left. What changed was the organization of experience. For a while, consciousness contained very little explicit reference to the person having it. And this raises a quiet question about the self you usually feel so continuously. If the sense of me can grow faint while perception, intelligence, and skilled action continue, perhaps self-awareness is not the container in which every experience must occur. Perhaps it is itself another experience, important, powerful, usually present, but capable of stepping into the background when the world becomes interesting enough to no longer require a narrator. Music can make your sense of self fade into the background. A piece of music can sometimes become so absorbing that, for a few minutes, you stop feeling like a person listening to sound and begin feeling as though the sound is carrying you, your name, your plans, the room around you. Even the constant inner commentary about how you feel can become less prominent while rhythm, melody, tension, and release occupy more of experience. This effect is not mystical, and it does not require music to literally erase the self. Music recruits an unusually broad collection of brain systems at once. Auditory regions analyze pitch and timing. Memory systems recognize familiar patterns. Emotional circuits respond to expectation and surprise. And motor regions can become active even when your body remains still. A strong beat is especially interesting because the brain does not merely hear its rhythm. It begins predicting when the next beat should occur. This coupling between auditory and motor systems helps explain why your foot can start tapping almost automatically, and why rhythmic music can create such a powerful urge to move. Researchers call this synchronization entrainment, and it allows internal timing to become aligned with an external pattern. As the music continues, your attention can become increasingly organized around what will happen next. Whether a melody will resolve, when a chorus will return, whether a beat will drop where you expect it to. Musical pleasure often depends partly on this delicate relationship between prediction and surprise. If everything is perfectly predictable, music can become dull. If nothing can be anticipated, it may feel chaotic. The brain seems especially engaged when expectations are established and then satisfied, delayed, or cleverly violated. Reward-related regions, including parts of the striatum, can become involved during intensely pleasurable musical moments. And dopamine signaling has been linked to both anticipation and peak pleasure in music. This may help explain chills, the sudden shiver or goosebumps some people experience during emotionally powerful passages. But music can influence something even more intimate than pleasure. It can change how prominently you represent yourself. When you are deeply immersed in a song, attention may become oriented toward the evolving structure of the music rather than towards self-evaluation. You are no longer asking how you appear, what you should do next, or what yesterday meant. The continuous narrative normally wrapped around experience can become quieter because the music provides another structure for consciousness to follow. Familiar songs can deepen this further by binding sound to autobiographical memory. A few notes may restore the emotional texture of another time with astonishing speed. Not a perfect recording of the past, but a network of associations involving people, places, bodily states, and feelings. For a moment, your sense of self may feel less like a fixed observer standing outside the music, and more like something being reshaped by memory and rhythm from within it. In group settings, the boundary can soften in another way. Singing, dancing, or moving in synchrony with others has been associated with increased feelings of social connection, perhaps because multiple nervous systems are coordinating their timing around the same external pattern. None of this means that music makes people literally become one mind, and the effects vary enormously between individuals, cultures, and pieces of music. What it does show is that the sense of being a separate self demanding constant attention is more flexible than it usually feels. Sometimes a melody becomes important enough that the mind stops narrating itself so loudly. The body follows rhythm. Expectation leans toward the next note, Memory opens doors without words, and for a little while, you do not disappear. You simply become less interested in watching yourself exist. The music fills the foreground, and the person listening becomes quiet enough to almost vanish behind it. A powerful story can push the real room almost completely out of awareness. Few printed sentences can make four walls lose their importance so completely that someone may speak your name and, for a moment, seem to be calling you from very far away. Nothing has happened to the room. The chair beneath you still presses against your body. Light still reaches your eyes. Sounds still enter your ears. Yet consciousness can become dominated by people and places that physically exist nowhere around you. Psychologists often describe this experience as narrative transportation, a state in which attention, emotion, and mental imagery become strongly engaged with the world constructed by a story. Stories are unusually powerful because the brain does not process them merely as strings of words. As you follow a narrative, you build an internal model of what is happening, who is present, what each person wants, where events are taking place, what caused the current situation, and what might happen next. Researchers sometimes call this a situation model. If a character walks from a kitchen into a garden, you update your representation of location. If a trusted person reveals a betrayal, you revise your model of relationships and motives. If danger approaches, you begin predicting possible outcomes before the author tells you which one occurs. The story, therefore, becomes a continuously updated, simulated environment, not simply information stored sentence by sentence. Brain imaging research supports this broader view. Reading about actions can engage regions associated with understanding movement. Language describing sensations can interact with sensory-related areas, and emotionally charged scenes recruit systems involved in evaluating real emotional significance. This does not mean the brain literally mistakes fiction for reality. You can know perfectly well that a fictional character does not exist while still experiencing genuine suspense about what will happen to them. The distinction between knowledge and response is crucial. The story is imaginary, but your emotional reaction is biologically real. Your heart can accelerate during a frightening chapter. Your face can respond to a character's embarrassment, and tears can appear over an event you know was invented by another human being. One reason the physical room can recede during this process is that attention is being consumed by the construction and maintenance of the narrative world. Words on a page provide relatively sparse information, yet your mind supplies enormous amounts of structure. The author writes that a character enters an abandoned house, but you may automatically generate a sense of darkness, distance, silence, temperature, and architecture without any of those details being fully specified. Memory contributes fragments from places you have seen. Expectations fill gaps, and imagination combines them into a scene that feels spatially coherent. Film can intensify this by supplying visual and auditory information directly, but even a novel can create a remarkably vivid sense of presence because the brain is not waiting for a complete picture. It is actively constructing one. This helps explain why an interruption can feel almost physically jarring. When someone suddenly speaks to you during an absorbing story, consciousness must reorganize itself from the fictional situation back toward the actual environment. The character's danger becomes irrelevant. The room regains priority. Your own body and immediate goals return to the foreground. You may even need a second to remember where you are, not because you truly believed you had traveled anywhere, but because the model dominating attention belonged somewhere else. Stories exploit one of the most extraordinary abilities of human consciousness, the capacity to experience events that are absent. Through language alone, you can care about people who never lived, fear dangers that cannot reach you, and mentally inhabit places no one ever built. And perhaps this is why closing a powerful book can create such a peculiar silence. The physical room has been present the entire time, patiently surrounding you. But for a while, another world was more psychologically real, not because it replaced reality, But because consciousness gave it the rare privilege of becoming the place where your experience was happening, some people experience mental images almost as vividly as real scenes. Close your eyes and picture a red apple, and what happens next may be radically different from what happens inside another person's mind. For some people, there is only a faint suggestion of shape and color, but for others, the apple can appear astonishingly rich. Glossy skin, a bright highlight along one side, a green stem, tiny imperfections, even a convincing sense of depth. At the far vivid end of this spectrum is a trait researchers call hyperphantasia, in which voluntary mental imagery can feel exceptionally intense and, subjectively, may approach the vividness of perception itself. This does not mean that someone with hyperphantasia normally mistakes imagination for an object physically standing in front of them. They generally know the image is internally generated. The difference is in the phenomenal richness of the experience. How bright, detailed, stable, colorful, and lifelike that internal scene feels. Mental imagery is possible because seeing something and imagining it recruit partly overlapping machinery. When you actually look at a face, visual regions analyze its contours, features, color, and spatial relationships using information arriving through the eyes. When you deliberately imagine that face, information can travel in the other direction, with memory and higher-level brain systems helping reactivate parts of those visual representations, despite there being no corresponding object on the retina. Individual differences in the strength and organization of these processes appear to contribute to why one person's mind's eye can be faint, while another person's feels almost cinematic. Researchers have even found physiological traces of imagery strength. Normally, your pupils constrict when you look at something bright and elate in darkness, but imagining bright and dark objects can also produce smaller versions of these changes. And the size of the imagery-related pupil response is associated with reported imagery vividness. That is an extraordinary detail, because it means a picture that exists only in the mind can influence a bodily response normally associated with actual light. Vivid imagery can also make memory and imagination feel unusually sensory. Someone may recall a childhood bedroom not merely as a list of facts, but as an internally reconstructed scene, or read a description and spontaneously generate faces, architecture, colors, and movement with remarkable richness. Yet vividness is not the same as accuracy. A highly detailed mental image can contain invented features just as an ordinary memory can, because imagination is constructive rather than photographic. Seeing something clearly inside your mind does not guarantee that the details correspond to what actually happened. Hyperphantasia is therefore not a supernatural ability and not evidence of a perfect internal camera. It is an extreme variation in how strongly some people experience mental imagery. Current research also suggests that imagery is not a single universal dial. Visual, spatial, auditory, tactile, and other forms of imagery can vary within the same individual. And once you realize how large those differences can be, a quiet assumption about other minds begins to fall apart. When two people are told to picture a beach, they may understand exactly the same instruction while having profoundly different conscious experiences. One may receive little more than the concept of sand and ocean. Another may internally see sunlight trembling across the water, shadows beneath distant clouds, and individual waves rolling toward a shore that does not exist anywhere outside the mind. Both are imagining, both know where they are, yet behind closed eyes, the private worlds they enter may barely resemble one another. Some people have almost no mental images, yet their thinking works normally. Ask someone to picture the face of a person they love, and they may know every important detail while seeing almost nothing at all. They can tell you the person has dark hair, narrow eyes, a familiar smile, perhaps a small mark beside the nose. Yet when they search for an internal picture, there may be no face waiting for them, no faint photograph, no blurry outline, sometimes no voluntary visual experience whatsoever. This variation is known as aphantasia, a marked reduction or absence of voluntary visual mental imagery. It has become one of the clearest demonstrations that thinking does not require everyone to experience thought in the same sensory form. Aphantasia is not simply poor eyesight, and does not mean that someone cannot recognize objects, understand visual information, remember facts about appearance, plan, reason, or live an ordinary intellectual life. People can know what something looks like without consciously seeing a representation of it. Research comparing people with aphantasia to those with typical or very vivid imagery has found that aphantasic participants can achieve similar accuracy on a range of tasks involving shapes, colors, faces, words, and spatial relationships, although some studies report differences in speed, confidence, or the strategies used to reach the answer. Instead of reconstructing a visible scene, one person might rely more heavily on semantic knowledge, knowing that a zebra has stripes rather than visually inspecting an imagined zebra. Another may use spatial relationships without producing a rich picture, representing where things would be rather than what they would visibly look like. Researchers have also found evidence that object imagery and spatial imagery can vary partly independently, meaning that saying someone cannot visualize can hide important differences in how their cognition actually works. The phenomenon becomes even stranger when dreams enter the picture. Some people who report little or no voluntary visual imagery while awake still report visual dreams, suggesting that deliberately constructing an image and having imagery arise spontaneously during sleep are not necessarily the same process. Physiological experiments add another layer. When people with typical imagery imagine bright and dark shapes, their pupils can respond in the direction expected from imagined brightness. In one study, participants with aphantasia showed normal pupil responses to actually seeing bright and dark stimuli, but lacked the same imagery-driven response, providing an objective sign consistent with their reports of reduced visual imagery. Yet none of this means an aphantasic mind is empty. Language can remain rich, abstract reasoning can remain intact. Creativity does not require an internal movie screen. A novelist can understand characters through concepts, emotions, relationships, and language without literally watching scenes unfold internally. A programmer can manipulate rules. A musician may think through sound. A scientist may reason through propositions or spatial structures. Current evidence therefore treats aphantasia primarily as a variation in conscious imagery, rather than a simple measure of intelligence or imagination itself. And recent population studies confirm that it represents one end of a broad distribution of imagery vividness. The deeper surprise is what this tells you about the word imagine. You may have spent your whole life assuming that when another person says they are picturing something, their inner experience resembles yours. There was rarely any reason to ask. Mental images are private. Unlike photographs, they cannot be placed on a table and compared. Aphantasia exposes that hidden assumption. Two people can solve the same problem, remember the same room, recognize the same face, and understand the same description, while the conscious experiences supporting those abilities are profoundly different. One mind may think in pictures, another may know without seeing, and both can arrive at the same answer, quietly revealing that the route thought takes through consciousness is far less universal than the world outside us ever led us to believe. Your imagination can fill consciousness even while your eyes remain open. Your eyes do not have to close for the world inside your mind to become more vivid than the one falling onto your retinas. You can stare through a train window while mentally seeing a room you left years ago. Look directly at a blank wall while rehearsing tomorrow's conversation. Or continue facing someone while an imagined scene unfolds so strongly that the visible surroundings become little more than a backdrop. This is possible because visual experience is not produced only by information traveling upward from the eyes. The brain also sends information in the opposite direction, using memory, expectation, and imagination to reactivate patterns associated with things that are not physically present. When you voluntarily imagine a face, a landscape, or an object, parts of the visual system involved in representing real visual features can also become active. although imagined and perceived scenes are not identical in either strength or neural organization. Your eyes may therefore continue delivering information about the actual room while internally generated activity constructs something entirely different. Usually the two remain easy to distinguish because real perception is anchored by strong, continuously changing sensory input, while imagination depends more heavily on internally generated signals. But consciousness has limited space for detailed processing, so when an internal scene becomes demanding or emotionally important, the external scene can lose prominence even though it never stops reaching the brain. You may discover this when planning a difficult conversation. Your gaze rests on an ordinary object, but what occupies experience is the imagined face of the other person. The words you might say, the expression you expect them to make, perhaps even the imagined sound of their reply. The physical object remains visible enough that you could respond if something suddenly changed, yet it is no longer what the moment feels primarily about. Researchers sometimes distinguish imagery from perception, partly by describing the different direction in which information is being constructed. Perception begins strongly with sensory input, while imagery relies more on stored representations and top-down activity. The two can even interact. Imagining a visual pattern can influence later visual judgments, and strong sensory input can interrupt or compete with imagery, showing that the inner picture and the outer picture are not completely isolated systems. None of this means imagination literally projects a private movie into the world, or that ordinary visualization is hallucination. In typical imagination, you retain the knowledge that the imagined object is not physically there. What changes is which source of information becomes most important to consciousness. This may be why you can look straight ahead and later realize that you barely registered what was in front of you. The eyes remained open, but seeing is not determined by the eyelids alone. Conscious vision emerges from a negotiation between what the world supplies and what the brain brings with it. Sometimes the external scene wins almost completely. Sometimes memory and imagination become strong enough to occupy the center, while reality waits quietly around the edges. And in those moments, you discover that the mind does not need darkness to create another place. It can build one in full daylight, directly on top of a world your eyes never stopped receiving. Daydream can briefly become more absorbing than the world in front of you. Chatteso. Few seconds can pass in which the most important place in your experience is somewhere that does not exist. You may be waiting in line when an imagined future begins unfolding, sitting at a desk when you replay a conversation differently, or walking through a familiar building while mentally exploring a life you might someday live. Unlike deliberate visualization, a daydream often develops with little planning. One thought invites another. A memory combines with a possibility, and before long, attention has become organized around an internally generated episode with characters, events, emotions, and consequences of its own. Psychologists commonly place daydreaming within the broader category of mind-wandering, but the experience can be richer than a simple loss of concentration. Your mind can construct what amounts to a temporary simulation, allowing you to rehearse future events, reconsider social situations, explore desires, or combine fragments of memory into scenarios that have never occurred. This capacity may be useful precisely because the brain does not have to wait for reality in order to test possibilities. You can imagine giving an answer before the interview happens. Picture how someone might react before you speak to them, or mentally try several futures without paying the real-world cost of living through each one. But internal simulation requires processing resources. When it becomes absorbing, the brain can become less responsive to ordinary information arriving from the environment, a phenomenon researchers studying mind-wandering sometimes describe as perceptual decoupling. The outside world has not vanished. Rather, ongoing sensory information receives less detailed processing because cognitive resources are supporting the internal train of thought. Experiments have found that during episodes of mind-wandering, people may respond less strongly or less reliably to task-relevant external events, which helps explain why someone can look directly at material in front of them while their actual experience is dominated by something else. The transition can be especially powerful when the daydream carries emotion. An imagined success can produce anticipation. An invented argument can create genuine irritation. And a future loss that has never occurred can briefly make the present feel sad. The scenario is fictional, but the nervous system responding to its meaning is real. Yet ordinary daydreaming is not a failure to recognize reality. You usually retain a background understanding of where you are and a sufficiently important event, a person calling you, an unexpected obstacle, an urgent demand, can rapidly restore the external world to priority. What makes the experience fascinating is how little physical material the mind needs in order to construct something compelling enough to compete with reality. No actual conversation is occurring. No future room surrounds you. No alternate version of your life is physically unfolding. And still, consciousness can temporarily organize itself around all of them. Then the daydream breaks. The cue moves. Someone asks a question. Your surroundings suddenly regain detail, and you return to a moment that had been continuing without you giving it much importance. Perhaps this is one of imagination's quietest powers. It does not merely show you things that are absent. For brief periods, it can make absence feel more relevant than presence, allowing a world made entirely from memory and possibility to become the place where your attention chooses to live. Something you only imagine can still change your heartbeat and breathing. Your body can begin preparing for an event that has never happened, simply because your mind has made it vivid enough to matter. Picture yourself standing at the edge of a high balcony, waiting backstage before an important speech, or hearing footsteps behind you on an empty street. And even while sitting safely in a quiet room, you may notice your breathing change, your pulse quicken, your palms become warmer, or your muscles tighten. The imagined scene has no physical force, yet the nervous system does not respond only to what is happening outside the body. It also responds to what the brain predicts, remembers, and simulates. When you construct an emotionally meaningful situation, regions involved in evaluating threat, reward, memory, and bodily regulation can become active together, influencing the autonomic nervous system that controls functions such as heart rate, sweating, blood vessel activity, and aspects of breathing. This is why imagining something frightening can produce genuine physiological arousal, and why mentally rehearsing a calming scene can sometimes have the opposite effect. The response is usually weaker and more variable than what would happen during an actual emergency, because real sensory evidence strongly constrains the brain's interpretation of danger, but imagination can still push the body in a measurable direction. Athletes make use of a related principle when they mentally rehearse movements. Motor imagery does not contract muscles in exactly the same way as physical performance, yet imagining an action can activate parts of the neural systems involved in planning and preparing that action. Emotional imagery works similarly by preparing the body for what the imagined situation would require. If you vividly rehearse an argument, your body may begin behaving as though confrontation is approaching. If you repeatedly imagine failure before an important event, the simulation can produce real tension long before anything has actually gone wrong. This does not mean thoughts magically create external events, nor does every imagined danger harm you. It means the brain evolved to use internal models as preparation. Waiting until a threat physically arrives before changing the body would often be too late, so prediction is built into regulation. Memory can trigger the same machinery because remembering and imagining both reconstruct situations from stored information rather than simply replaying a perfect recording. That is why a memory of embarrassment can make your face feel warm again, or why picturing someone you miss can produce a physical ache despite their absence. The body is responding not to fiction as fiction, but to the meaning the nervous system has assigned to the mental event. And this creates an unusual bridge between imagination and physiology. A scene can exist nowhere outside you and still change the rhythm inside your chest. No one else can see the situation. No object has entered the room. And yet your heart and lungs may already be adjusting to a world made entirely from possibility. Perhaps this is why imagination can comfort you and frighten you with such surprising force. The mind does not merely describe what might happen. Sometimes, for a few moments, it begins preparing the body as though that imagined future has already started. You can turn attention inward and suddenly notice sensations that were there all along. Your body is sending signals to your brain every second, yet most of them can remain almost invisible until you deliberately search for them. Notice the pressure where your feet meet the floor, the contact between your back and the chair, the temperature inside your hands, the movement of your abdomen, the position of your jaw, or the faint pulse somewhere in your neck. And sensations that seemed absent a moment ago may suddenly become obvious. They were not necessarily created by attention. Many were already present, but had remained below the level of conscious importance. The nervous system continuously receives information from both the surface and interior of the body, including signals related to pressure, stretch, temperature, muscle state, heartbeat, breathing, digestion, and other physiological conditions. Part of this internal sensing is known as interoception, and regions including the insular cortex participate in integrating bodily information into your moment-to-moment sense of physical state. But consciousness cannot present every internal signal with equal intensity. If you were continuously aware of every point where clothing touched the skin, every small movement in the digestive tract, every heartbeat, and every change in muscle tension, the body could become an overwhelming source of noise. Instead, most stable sensations remain in the background unless they become strong, unexpected, emotionally important, or deliberately attended to. Turning attention inward changes that balance. A faint sensation that had been competing unsuccessfully with sights, sounds, thoughts, and goals can suddenly receive enough processing priority to enter awareness. This is why body scanning exercises can reveal surprising details: tension around the eyes, pressure in the tongue, asymmetry in the shoulders, warmth in one hand, or a subtle rhythm in the abdomen that had been present for minutes without being consciously noticed. Researchers studying interoceptive attention have found that focusing on internal bodily signals changes activity in brain systems involved in representing those signals, although people vary greatly in how accurately they can detect particular processes, such as their own heartbeat. Importantly, feeling something more strongly after attending to it does not always mean the underlying physical event has intensified. Attention can increase perceptual salience. The same principle helps explain why a minor itch can become almost impossible to ignore once you focus on it, or why waiting for a headache to worsen can make every small sensation in the head feel significant. Expectation also matters. When you actively search for a sensation, ambiguous bodily information may be interpreted in light of what you expect to find. This is why careful body awareness can be useful, but obsessive monitoring can sometimes become misleading or uncomfortable. The brain is not reading the body like a perfect instrument panel. It is interpreting noisy internal data through attention, context, and expectation. Yet the simple act of noticing reveals how much of embodied life normally remains outside the spotlight. Your heart was beating before you listened for it. Your muscles were holding you upright before you felt their effort. Your skin was in contact with the world before you examined the boundary. When attention turns inward, you do not suddenly acquire a body that was absent a second ago. You discover that consciousness had been standing on top of a quiet landscape of sensation all along, feeling only the parts that had become important enough to speak. Simply, focusing on your breathing can change what being awake feels like. A few ordinary breaths can make the same waking moment feel strangely different without changing anything in the room around you. Sit quietly and place your attention on the sensation of air entering the nose, the small expansion of the chest, the pause before the next exhalation, and something subtle begins to happen. Waking experience becomes less dominated by whatever normally pulls you forward. This is not because breathing contains a hidden mystical power, but because sustained attention changes how consciousness is organized. Most of the day, awareness is pulled toward goals, conversations, screens, memories, predictions, and problems that seem to demand an answer. The breath is unusual because it offers a continuously changing sensory event that is always present, but usually too ordinary to matter. When you deliberately stay with it, you give the brain a simple, repeating target instead of allowing attention to follow every new stimulus that competes for it. Researchers studying breath-focused attention have found changes in brain systems involved in attentional control, monitoring and regulation, and the practice can make people more aware of moments when focus has drifted and returned. But the subjective effect can be more interesting than simply better concentration. Time may begin to feel more granular because you are noticing events that normally disappear into the background. The coolness of inhaled air, the warmer exhalation, the slight delay between breaths, the movement of the ribs. A minute that would ordinarily vanish while you scroll or plan can suddenly contain dozens of distinct sensations. Breathing can also interact with arousal. Slow, comfortable breathing, especially when exhalation is not rushed, can influence autonomic regulation and is often associated with a calmer physiological state, partly through changes in respiratory and cardiovascular rhythms. This does not mean that one breathing exercise can erase anxiety, control the nervous system at will, or guarantee relaxation. People differ, and forcing the breath can sometimes make someone more uncomfortable rather than less. The important point is that attention to breathing changes both what you notice and, if you alter the breathing pattern, some of the bodily signals feeding back into the brain. This creates an unusual loop. You attend to the body's rhythm may change slightly, and the changed bodily rhythm becomes new information for consciousness. After a few minutes, the experience of simply being awake can feel less like racing from one mental event to another, and more like inhabiting a sequence of small physical moments. Sounds may seem clearer because you are no longer mentally chasing them. Thoughts may still appear, but they become easier to notice as interruptions rather than unquestioned destinations. Even the boundary between doing and being can feel different because breathing gives you something to attend to that does not need to be completed. There is no final breath to achieve, no score to improve, no problem that must be solved before the next inhalation arrives. And perhaps this is why such a simple act can alter the texture of wakefulness. The world has not slowed down. Your brain has not entered another state of existence. You have simply stopped asking consciousness to be everywhere at once and allowed it to remain beside one repeating event long enough to discover how much detail an ordinary waking moment was hiding. Meditation can change your relationship with thoughts without making them disappear. Meditation does not require your mind to become empty, and discovering that may be one of the most important things the practice can teach you. Sit down with the intention of having no thoughts, and you will probably fail almost immediately. A memory appears, a plan forms, an irritation surfaces, a song begins playing internally, or your mind starts commenting on how badly you are supposedly meditating. The mistake is assuming that meditation is meant to stop this machinery. Many forms of mindfulness practice aim at something different, to change what happens after a thought appears. Instead of automatically following every idea, judging it, arguing with it, or treating it as an instruction, you practice recognizing it as a mental event, and then returning attention to a chosen anchor, such as the breath, bodily sensation, or sound. Psychologists often describe part of this shift as decentering, the ability to experience thoughts as temporary products of the mind rather than as perfect descriptions of reality or unquestionable statements about the self. The distinction sounds small, but it can profoundly alter experience. I am going to fail, and I am noticing the thought that I am going to fail contain nearly the same words, yet they place you in different relationships with the prediction. In the first, the thought can become the world. In the second, the world has room to contain both the thought and the awareness that the thought is occurring. Research on mindfulness-based approaches suggests that repeated practice can reduce rumination and helps some people respond less automatically to distressing mental content. Although effects vary, and meditation is not a universal treatment for psychological problems, studies of experienced meditators also find differences in activity and connectivity within brain systems involved in attention, self-referential processing, and emotion regulation. But these findings should not be interpreted as evidence that meditation produces one simple or permanent meditation brain. Different techniques train different skills, and individual experiences vary widely. One especially important finding from psychology is that directly trying to suppress an unwanted thought can sometimes make it return more persistently. Meditation often takes the opposite approach. The thought is allowed to exist without being given unlimited attention. A worry arrives, you notice it. A memory appears, you recognize it. An internal judgment says this is pointless. That judgment itself becomes another object of awareness. Nothing needs to be forcibly removed. Over time, this can reveal how temporary much mental content actually is. Thoughts that initially feel permanent often change when they are neither fed nor fought. One fades, another arrives, emotion rises around it, and eventually that too changes. The practice therefore teaches something less dramatic than mental silence, but perhaps more useful. Thoughts can be present without controlling the next action. You can feel anger without immediately speaking from it. You can experience an anxious prediction without treating it as evidence. You can remember something painful without needing to solve the entire past in that moment. This does not create complete distance from every thought, and even experienced meditators still become distracted, emotionally caught, and absorbed in their own stories. The difference is that recognition may come sooner, and returning may become easier. Meditation, at its most grounded, is not an attempt to defeat thinking. It is repeated practice in discovering that awareness is larger than whichever thought happens to be loudest. The mind continues producing weather, but you slowly learn that you do not have to become every storm that passes through it. A flow state can make self-consciousness almost disappear while you keep performing. There are rare stretches of time when you are doing something difficult at a high level, yet the person inside your head who normally comments on everything seems to go silent. A musician moves through a demanding passage without mentally naming each note. A climber responds to the next hold without wondering how they look. A programmer solves one problem after another without checking the clock. And an athlete can finish a sequence only to realize that almost no attention had been spent thinking about themselves. Psychologists call this kind of experience flow, a state of deep task engagement most closely associated with work by Mihaly Csikszentmihalyi. Flow tends to become more likely when several conditions come together. The activity has clear goals, feedback arrives quickly enough to guide adjustment, and the challenge is demanding without being so far beyond your skill that it becomes overwhelming. If the task is too easy, boredom can appear. If it is far too difficult, anxiety may dominate. Somewhere between those extremes, effort can become unusually well matched to ability, and consciousness begins organizing itself around the activity rather than around the person performing it. This is an important distinction because flow does not mean the brain stops monitoring performance. In fact, the opposite may be true in a practical sense. You continue detecting errors, adjusting timing, selecting actions, and responding to feedback, sometimes with exceptional precision. What can diminish is explicit self-evaluation. The layer of thought asking whether you are impressive, whether you are failing, what someone else thinks of you, or how long you have been working. Research on flow has linked the state to changes in attention, reward processing, arousal, and self-related cognition, although scientists do not yet agree on one simple neural signature that defines every flow experience. Some theories have proposed temporary reductions in particular forms of prefrontal self-monitoring, but the evidence is more complicated than the popular claim that the thinking brain switches off. Skilled performance still requires sophisticated neural coordination. What seems to change is how those resources are organized. The task becomes the dominant structure of experience, and information irrelevant to the goal receives less priority. This can also alter time perception. During flow, people often report that time seems to pass unusually quickly, or occasionally that individual moments feel expanded during very fast performance. Clock time has not changed. What changes is how often attention is allocated to monitoring time itself. When consciousness is occupied by a continuous sequence of meaningful challenges and immediate responses, there may be fewer moments in which you step outside the activity and ask how long it has been happening. The reward of flow is also distinctive. You may begin an activity for an external result, to win, finish, earn, or improve. But while deeply engaged, the activity can become rewarding in itself because every successful adjustment creates the next challenge. This helps explain why people can remain intensely involved in painting, coding, sport, music, games, or craftsmanship, even when nobody is watching. Yet flow is not automatic excellence, and feeling in the zone does not guarantee perfect performance. Nor is every enjoyable or absorbed moment a true flow state. The concept describes a particular pattern of engagement, not a mystical mode of consciousness. Still, it reveals something profound about the self you normally carry everywhere. Your identity does not have to vanish for self-conscious thought to become temporarily unnecessary. You can continue making decisions, using memory, responding intelligently, and performing complex actions while the internal narrator becomes almost silent. And when the state breaks, perhaps because you make a mistake, someone interrupts you, or the task ends, the familiar self returns to the foreground. You become aware of your body, the time, the room, perhaps even how well you were doing. Only then do you notice what was missing. For a while, you were not standing outside yourself evaluating the performance. You were so completely organized around the act itself that there seemed to be no distance between the one doing and the thing being done. Extreme concentration can make the rest of the world seem to fade away. Concentration can become so narrow that an event close enough to touch you may fail to become an important part of your experience. You are trying to identify a tiny error in a complicated document, guide a delicate tool through a precise movement, follow a rapidly changing game, or solve a problem that demands every available piece of attention. And suddenly someone tells you they called your name twice. The sound reached your ears, the room remained around you, and nothing physically blocked the signal. Yet the event never gained enough priority to interrupt what you were doing. This effect reveals that intense concentration is not simply more attention. It is a redistribution of limited processing resources. Research on perceptual load has shown that when a task consumes substantial attentional capacity, people can become less likely to process unrelated information that would otherwise distract them. In experiments, irrelevant objects or sounds that are easily noticed during a simple task can produce much smaller effects when the main task becomes demanding. Under some conditions, people can even miss striking events occurring in plain view or fail to report clearly audible stimuli, phenomena related to inattentional blindness and inattentional deafness. The senses themselves have not switched off. Early sensory processing may still occur, but whether information reaches a level where it guides behavior, becomes reportable, or enters memory depends partly on competition for processing priority. This is why the phrase "I didn't hear you" can sometimes be psychologically true, even when the auditory system physically received the voice. The signal existed, but the mind was committed elsewhere. Extreme concentration also changes how the environment is represented. Features directly relevant to the task can become unusually detailed, while irrelevant aspects remain coarse or poorly remembered. A surgeon may be exquisitely aware of millimeter-scale changes within an operative field, while later having little recollection of incidental events elsewhere in the room. A competitive player may track the position and timing of relevant objects while barely registering the audience. Someone debugging complicated code may become highly sensitive to a misplaced character while ignoring a conversation nearby. These examples involve different skills, but they share a principle. What reaches consciousness with high resolution is strongly shaped by current goals. This narrowing can be extraordinarily useful. Complex tasks often require protection from distraction, and a brain that gave equal importance to every nearby sound, movement, sensation, and thought would struggle to maintain a difficult sequence. But the same mechanism creates risk when important information appears outside the current focus. Pilots, medical teams, drivers, and other professionals working under heavy cognitive load are trained to use checklists, cross-checks, alarms, and communication procedures, partly because intense task focus can make unexpected signals easier to miss. Expertise helps, but experts are not immune. In fact, knowing what usually matters can sometimes make attention even more strongly organized around expected information, which is efficient until the unexpected becomes critical. This is also why sudden interruptions can feel almost violent during deep concentration. The brain must abandon one carefully maintained set of priorities and rapidly rebuild another, and that transition carries a cognitive cost. You may need several moments to reconstruct where you were, especially if the task required holding fragile intermediate information. The strange thing is that none of this usually feels like the world is literally disappearing. The room still seems present. You retain a broad sense that objects and people surround you. Yet when someone asks what happened beyond the narrow target of concentration, you may discover how little of that surrounding world was actually processed in detail. Extreme focus does not remove reality. It changes the hierarchy inside it. One small region becomes urgent, precise, and richly represented, while everything else is allowed to remain vague enough to wait. And for a while, consciousness can live inside that narrow corridor so completely that the rest of the world does not vanish from existence. It simply stops being important enough to arrive. Fatigue can make conscious awareness narrower and less stable. Fatigue does not always announce itself by making you feel ready to collapse. Sometimes it quietly changes how much of the world your mind can keep reliably present. After many hours awake, you may still be able to talk, walk, work, and convince yourself that you are functioning normally, while your ability to maintain stable attention is already becoming less dependable. Sleep deprivation affects several interacting systems involved in alertness, executive control, sensory processing, and decision-making. And one of its most important effects is increased variability. Performance does not simply become uniformly slower. Instead, you can have stretches in which you respond almost normally interrupted by brief lapses when reaction times lengthen, information is missed, or attention seems to momentarily loosen its grip. This is why fatigue can be deceptive. A person may complete several actions successfully and use those successes as evidence that they are fully alert, even though the probability of the next lapse has increased. Researchers commonly measure this with sustained attention tasks such as the psychomotor vigilance test, where sleep loss produces more unusually slow responses and missed signals, rather than merely shifting every response by the same amount. Inside the brain, prolonged wakefulness changes activity across networks involved in maintaining attention, including frontal and parietal regions, while the thalamus and other systems that help regulate alertness can also behave differently as sleep pressure rises. At the same time, a chemical called adenosine accumulates during waking and contributes to the biological pressure for sleep, interacting with your circadian system, which can temporarily make you feel more or less alert depending on the time of day. This explains a familiar paradox. You can sometimes feel a second wind late in the evening, even though the need for sleep has not disappeared. Fatigue can also narrow the range of information you successfully manage. When cognitive resources are strained, immediate or central demands may receive priority, while peripheral details, competing goals, and subtle changes become easier to overlook. You may reread instructions, forget what was said moments earlier, miss a small warning, or become unusually fixated on completing one part of a problem while failing to reconsider the larger situation. Emotional regulation can become less stable as well, making small frustrations feel more significant and reducing the patience required to reassess a decision. None of this means an exhausted brain simply becomes a weaker version of a rested one. It becomes a more variable system, sometimes functioning well enough to hide its own instability. That is especially dangerous during monotonous activities such as long-distance driving, night work, or monitoring equipment, because long periods without dramatic events provide few external signals strong enough to restore alertness. Caffeine can temporarily reduce some effects of sleepiness by blocking adenosine receptors, but it does not replace sleep or restore every cognitive function to normal. The deeper problem is that your subjective feeling of alertness is not a perfect instrument for measuring your actual performance. People who are sleep-deprived can underestimate how impaired they have become, particularly after adapting psychologically to several nights of insufficient sleep. Consciousness, therefore, does not simply remain equally wide and clear until the moment you fall asleep. It can become thinner, more fragile, and more inconsistent while you are still undeniably awake. The world remains in front of you, but fewer pieces may be held securely at once, and the continuity you normally trust can begin developing tiny cracks. Fatigue teaches an uncomfortable lesson. Feeling awake is not the same as possessing a fully stable waking mind, and sometimes the first thing exhaustion weakens is your ability to notice how much it has already taken away. You can briefly lose conscious awareness without realizing you fell asleep. A few seconds of your life can disappear without leaving behind the feeling that sleep ever happened. This can occur during a microsleep, a very brief intrusion of sleep that is especially likely when someone is severely fatigued, sleep-deprived, or performing a monotonous task. A microsleep may last only a few seconds, and from the outside it can be subtle. The eyelids may droop or close, the head may nod, a response may stop, or behavior may simply pause. Brain recordings can show patterns consistent with a transition towards sleep, even when the person afterward insists that they were awake the entire time. The disturbing reason is simple. You cannot reliably remember an interval during which the systems required to maintain awareness and form a continuous memory were no longer functioning in the ordinary waking way. Subjectively, there may be a moment before the gap and then a moment after it, with no experienced darkness placed between them. Consciousness does not necessarily present a message saying, "You are now absent for 3 seconds." If nothing is experienced or encoded during the interruption, there may be nothing available afterward from which to construct the sensation of having been asleep. Microsleeps emerge because the pressure for sleep can become strong enough that wakefulness is no longer maintained uniformly. Sleep and wake are not always perfectly global states in which every brain system changes together at exactly the same instant. Research has found that during extreme sleep pressure, sleep-like patterns can appear locally in parts of the brain, even while the person remains behaviorally awake. And as the instability increases, more complete lapses can occur. This helps explain why someone fighting sleep can move through an uncanny sequence of partial failures. A sentence suddenly makes no sense. The eyes lose focus. A thought breaks apart. The head jerks, and then awareness seems to return with no clear memory of leaving. In a laboratory, these lapses can be detected through electroencephalography, eye measurements, and failures to respond to stimuli. On the road, however, the consequences can be catastrophic. At highway speed, even a few seconds without reliable awareness means traveling a considerable distance without effective monitoring of traffic, lane position, or unexpected hazards. This is why opening a window, turning up music, or trying to push through severe sleepiness is not a dependable solution. Such tricks may temporarily increase stimulation, but they do not remove the biological drive for sleep. Even caffeine has limits, particularly when sleep deprivation is substantial. The only true recovery from accumulated sleep pressure requires sleep itself. What makes microsleep philosophically strange is the way it exposes the relationship between consciousness and time. You normally experience your life as a continuous sequence, because each moment leads into another and memory stitches them together. But if conscious processing stops briefly and no memory is formed, the missing interval does not necessarily feel like an interval at all. Imagine two frames of a film placed directly beside each other after several frames have been removed. To the viewer who never sees the missing material, the cut can seem instantaneous. Something similar can happen to subjective time. You are looking at the road, screen, or page. Then you are looking again, perhaps slightly startled, with no internal record explaining what happened between those moments. This should not be confused with ordinary blinking, zoning out, or simple distraction. A true microsleep involves a genuine brief transition towards sleep, and confirming one scientifically requires more than merely feeling that time passed strangely. But when it occurs, the person experiencing it may be the least reliable witness to the gap. That is the unsettling lesson. Consciousness can vanish briefly without leaving behind an experience of vanishing. The absence itself produces no memory. You only return. And the missing seconds are defined not by what you remember happening, but by the fact that nothing seems to be there at all. Being awake and being conscious are not exactly the same thing. Open eyes can make a person look fully present, even when the inner world behind them may be profoundly reduced. And that simple fact forces science to separate two things that everyday language often treats as identical: wakefulness and consciousness. Wakefulness mainly describes a level of arousal, the brain and body being in a state capable of opening the eyes, maintaining sleep-wake cycles, and responding at least partly to the environment, while consciousness refers more broadly to having subjective experience, some form of awareness of the world, the body, or the self. The two usually travel together, which is why the distinction is easy to miss. You wake in the morning and awareness returns with it. You fall into deep dreamless sleep and both seem to recede. But neurology reveals cases where the relationship breaks apart. In what is now often called unresponsive wakefulness syndrome, historically known as the vegetative state, a person can open their eyes and cycle between periods that resemble sleep and wakefulness, while showing no reliable behavioral evidence of awareness. Brainstem systems that regulate arousal may be functioning enough to produce wake-like states, yet the large-scale cortical processes associated with meaningful conscious interaction appear severely disrupted. At the other extreme, REM dreaming shows something almost reversed. Your body is asleep and disconnected from normal waking behavior, yet an elaborate subjective world can unfold internally. You may see places, hear voices, experience fear, joy, movement, and even a temporary sense of identity despite being physically asleep in bed. This alone tells you that consciousness cannot simply be defined as having your eyes open or being able to move. Clinicians therefore assess patients along at least two broad dimensions: arousal and awareness. A person in a coma generally lacks sustained wakefulness and shows no signs of awareness, whereas someone in a minimally conscious state may display inconsistent but reproducible evidence of awareness, such as following a simple command on some occasions, visually tracking something meaningful, or producing behavior linked to the environment. These distinctions are medically important because outward behavior can be an imperfect window into inner experience. Severe paralysis, language impairment, motor damage, sedation, or fluctuating attention can make a conscious person difficult to detect. In rare cases, brain imaging has revealed signs of command following in patients who appeared behaviorally unresponsive, sometimes called cognitive motor dissociation, suggesting that internal awareness can occasionally exist without an obvious motor response. This does not mean every unresponsive patient is secretly fully conscious. The evidence must be interpreted carefully, and diagnosis remains difficult. What it does show is that consciousness cannot be read directly from the eyelids, muscles, or posture. Being awake is partly about whether the nervous system has raised the curtain. Being conscious is about whether there is, in some sense we still struggle to define, a performance occurring behind it. Most mornings, those two events happen together so seamlessly that you never separate them. But the brain can separate them, and once you know that, an ordinary statement like "I am awake" becomes unexpectedly incomplete. It tells you something about the state of your nervous system, but not everything about the existence or richness of the experience taking place within it. Consciousness can return gradually rather than switching on all at once. Coming back to consciousness can feel like opening your eyes into a world that has arrived before you have fully arrived inside it. After deep sleep, sedation, anesthesia, or certain neurological states, awareness may not reappear as a single clean event in which everything suddenly becomes normal. Instead, different capacities can recover at different speeds. A person may first react to sound or touch, then open their eyes, then begin following simple instructions, then recognize the room, and only later recover a stable sense of time, memory, and personal context. You may have experienced a mild version after being awakened abruptly. For several seconds you can see the ceiling and hear a voice while still having little idea what time it is, why you were asleep, or what you were supposed to be doing. That temporary confusion is called sleep inertia, but more dramatic examples appear during emergence from general anesthesia. Anesthesia does not simply press one universal consciousness switch. Different anesthetic drugs act on different molecular targets, but many ultimately disrupt the brain's ability to maintain the coordinated communication needed for ordinary conscious experience. Studies using electroencephalography and brain imaging suggest that loss and recovery of consciousness involve changes in communication among the cortex, thalamus, and other large-scale networks, particularly the ability of distant brain regions to exchange information in a flexible and organized way. During emergence, these patterns do not necessarily return everywhere at once. Basic arousal systems may recover before higher functions, such as orientation, memory formation, complex language, or reflective self-awareness. This helps explain why someone can respond to a command and later remember nothing about doing so, or briefly speak while still being confused about where they are. Memory is especially important here because your later story of "when I became conscious" depends on which moments were successfully encoded. There may have been partial awareness before your first durable memory, creating the impression that consciousness began later than it actually did. Researchers studying recovery from severe brain injury see an even wider range of gradual transitions. Patients can move from no observable response to occasional visual tracking, then inconsistent command following, then more reliable communication, sometimes over long periods. Recovery is rarely a smooth staircase, and improvement can fluctuate from hour to hour, which is one reason repeated assessment is so important. The deeper lesson is that consciousness appears to depend on several capacities that can come apart: arousal, perception, attention, memory, orientation, the ability to integrate information, and the ability to report what is happening. Your everyday waking mind bundles these so tightly that they feel like one thing. When the bundle is disrupted and then rebuilt, you can see the seams. First, there may be sensation without understanding, then recognition without context, then fragments of memory, then the familiar sense that you are here, in this place, at this time, as this person. The process can resemble dawn more than a light switch, not because consciousness is literally a brightness spreading across the brain, but because what you call being fully present may depend on many systems becoming coordinated again. And perhaps that is why the first clear moment after deep unconsciousness can feel so complete. You do not remember the pieces assembling. You simply notice somewhere along the way that the world has become yours again. General anesthesia can remove conscious experience without simply turning the brain off. The strangest part of general anesthesia is not that the brain becomes silent, but that it can remain astonishingly active while the world you normally experience seems to disappear. Before surgery, you may hear voices, feel the bed beneath you, recognize the room, and understand exactly where you are. Then anesthetic drugs enter the bloodstream, and sometime later another voice appears, telling you the procedure is over. It is tempting to imagine that the brain was simply switched off between those two moments, like a computer losing power, but measurements tell a much more complicated story. During general anesthesia, neurons continue firing, the brain continues consuming energy. Sensory signals can still travel through parts of the nervous system, and many basic functions continue under careful medical control. What changes dramatically is the organization of that activity. Different anesthetic drugs work through different molecular mechanisms. Propofol strengthens inhibitory signaling through receptors involving GABA, while ketamine acts primarily through a different system involving NMDA receptors. But despite their differences, sufficiently deep anesthesia can disrupt the patterns of communication that normally allow information from many parts of the brain to be combined into a coherent conscious scene. The issue seems to be less about whether neurons are active and more about whether distant regions can exchange information in the flexible, coordinated way associated with ordinary awareness. Under several common anesthetics, communication between frontal, parietal, thalamic, and sensory systems changes, and brain activity may become more stereotyped, fragmented, or dominated by rhythms that are very different from normal wakefulness. The thalamus, which participates in coordinating information between many cortical regions, changes its interactions with the cortex as well. Yet there is no single universal pattern shared perfectly by every anesthetic, which is one reason consciousness remains so difficult to reduce to one brain signal. Anesthesia also separates processes that normally feel inseparable. A body can still react reflexively to stimulation without that stimulation becoming a conscious experience. The nervous system may register aspects of sound even when you later report hearing nothing. Memory formation can be impaired separately from responsiveness, which is why anesthesiologists do not define successful anesthesia merely by whether a patient later remembers the operation. Their goals can include unconsciousness, amnesia, pain control, immobility, and physiological stability. And different drugs are often combined because these are not identical functions. Rarely, awareness during general anesthesia can occur, which is why clinicians monitor drug delivery and physiology carefully. Anesthesia is not an infallible magical state, but a medically managed alteration of brain function. What makes all of this so philosophically revealing is that the brain does not need to stop operating for your experienced world to disappear. Heart regulation continues. Cells exchange signals. Networks remain electrically alive. Yet the familiar unity in which sound, touch, memory, self, and surroundings become one ongoing present can dissolve. This suggests that consciousness may depend less on the sheer amount of brain activity than on what that activity is able to do together. A city can still contain millions of lights, while its communication network collapses. The buildings remain, electricity flows, but coordinated life across the city changes profoundly. The analogy is imperfect, yet it points toward the mystery anesthesia exposes. Somewhere between one pattern of organized neural activity and another, the room, the body, the passage of time, and the feeling of being someone inside a moment can all disappear without the brain itself disappearing. Then the organization changes again, and experience returns. The machine was never simply off. What vanished was something far harder to define, the particular way an active brain becomes a world you can actually be inside. A gap in consciousness can feel like no gap happened at all. You can lose an hour from experience and still feel, from the inside, as though almost no time separated the moment before from the moment after. Imagine looking at a clock before a procedure, then opening your eyes and seeing that 60 minutes have passed. Intellectually, you know the interval existed. Other people lived through it. Machines recorded it. Events happened inside it. Yet subjectively, there may be no corresponding stretch of darkness, waiting, silence, or emptiness. There is simply one experience moment followed by another. This exposes a strange property of consciousness. You cannot experience the absence of experience in the same way you experience something that is present. When you sit alone in a dark room for an hour, darkness still has duration because thoughts change. Bodily sensations shift. Sounds appear, boredom grows, memories arise, and your brain continuously generates events that allow time to be represented. But if conscious experience is genuinely absent, there may be no internal sequence from which a sense of duration can be constructed. Clock time continues, but subjective time has nothing to count. Memory makes this stranger because your sense of continuity depends partly on relationships between successive experiences. Ordinary life contains constant bridges. You remember beginning a sentence while reaching its end, remember entering the room while standing inside it, and carry fragments of the previous moment into the next. These overlapping traces give consciousness its smooth temporal texture. Remove the experiences in the middle, however, and the surviving moments can become psychologically adjacent. The last remembered event before the gap sits next to the first remembered event after it, even if the physical interval between them was enormous. This is one reason general anesthesia can feel instantaneous in retrospect, and why dreamless periods of sleep are often described similarly. You do not usually wake with an internal sensation of having personally endured 7 hours of nothingness. You infer the passage of time from the clock, daylight, fatigue, memory of going to bed, and changes in the world around you. There is an important caution here. Inability to remember an interval does not always prove there was no experience during it. Consciousness and memory are different processes. You can have an experience that later fails to be stored, as happens in some states involving drugs, neurological disruption, or even ordinary forgetting. Researchers studying anesthesia therefore distinguish between explicit recall and awareness, because a person's later memory cannot by itself provide a perfect record of whether any experience occurred. But when experience truly is absent, an even deeper problem appears. There is no subjective observer present to register how long the absence lasted. You cannot watch yourself not experiencing. You cannot become bored inside a state containing no awareness of boredom. You cannot think, this nothingness has lasted 20 minutes, because that thought would itself be an experience and would therefore end the absolute absence you were trying to describe. Philosophers have noticed versions of this puzzle for centuries, but medicine makes it concrete. A patient can be placed under anesthesia, undergo an operation filled with events, and later encounter the recovery room as though reality had been cut and rejoined. The missing interval is real in physical time, but strangely featureless in personal time. It resembles removing a section of film and attaching the surviving frames together. The world outside the film continues, but the sequence available to the viewer contains no felt duration corresponding to what was removed. And this raises an unsettling question about the time you believe you continuously inhabit. Perhaps subjective duration is not something consciousness passively receives from clocks. Perhaps it is something constructed from change, memory, sensation, and the continued presence of experience itself. When those disappear completely, time does not necessarily feel slow, empty, or endless. From your side of the gap, it may not feel like anything at all, and when consciousness returns, the future can seem to arrive immediately after the past. You can regain awareness before you fully understand where you are. You can become conscious enough to feel confused before you become conscious enough to explain what you are confused about. It happens in its mildest form when you are awakened abruptly in an unfamiliar room. Your eyes open, shapes are already visible, a sound may register. You may even sit up or answer someone, yet for several strange seconds the scene has no proper meaning. The ceiling is simply a ceiling. The voice is familiar but not yet connected to a reason. You know that you exist and that something is happening. But the larger coordinates of your life, where you are, what time it is, why you are there, what happened before this moment, have not fully assembled. This reveals that awareness and orientation are not the same mental achievement. Basic consciousness can contain sensations, feelings, and responses before the brain has reconstructed the contextual model that tells you how those sensations fit into your personal world. To know where you are, your brain must combine current sensory information with stored knowledge. Visual landmarks need to be recognized. Memories must be retrieved. The present scene must be linked to a recent sequence of events. Your internal representation of place relies on interacting systems that include the hippocampus and nearby medial temporal regions, while areas such as the retrosplenial cortex help connect spatial information with familiar environments and orientation. Frontal systems contribute to holding context, evaluating what is relevant, and recovering the larger goal structure of the moment. These processes usually work so quickly that waking feels instantaneous. Room, identity, time, and purpose seem to arrive together. But when the brain is emerging abruptly from sleep, sedation, fainting, or certain other disrupted states, the components can temporarily separate. One system may be awake enough to process a voice, before another has restored the memory, explaining whose voice it is. Your emotional system may react to unfamiliarity before your memory establishes that the room is safe. You can therefore experience the peculiar state of being present without yet being situated. Sleep researchers see related effects during confusional arousals, in which a person partially wakes from deep sleep and may sit up, speak, or behave in a disoriented way while higher-level understanding remains incomplete. A much milder version is common in ordinary sleep inertia, especially after sudden awakening from deep sleep, when reasoning, attention, and orientation can lag behind the simple fact of being awake. Similar temporary disorientation can occur during recovery from anesthesia, although the details vary with the drugs, the person, the procedure, age, and medical condition. What makes these moments philosophically interesting is that your normal sense of now is not merely delivered by the eyes. A room becomes your room only when perception meets memory. A date becomes today only when current information is connected to an internal timeline. Even the feeling that you know what you are doing depends on recovering the goals and events that led to this second. Consciousness can therefore return to a scene before the scene has become meaningful. You may first receive light, sound, pressure, perhaps unease. Then recognition arrives, then context. Then the story reconnects and you remember who you are within it. Usually this takes only moments, which is why you rarely notice how much reconstruction is involved. But during those brief intervals of disorientation, the machinery becomes visible. The world can already be present before it has become your world again. And for a few unsettling seconds, you discover that awareness is not the same as understanding where awareness has awakened. The brain can be highly active without producing ordinary conscious experience. Brain can be filled with electrical activity and still fail to produce the ordinary conscious world you are experiencing right now. This is one of the clearest reasons neuroscientists cannot simply look for more brain activity and call it consciousness. Neurons remain active during sleep, seizures, anesthesia, and severe disorders of consciousness. Sometimes that activity is dramatic enough to dominate an electroencephalogram, yet the person may have little or no ordinary awareness of the external world. Consider deep non-REM sleep. The cortex does not become electrically silent. Instead, huge populations of neurons alternate between periods of activity and relative silence in slow, coordinated rhythms. The brain is doing something substantial, but the rich, continuously updated waking world of objects, goals, and surroundings is greatly reduced or absent during many of these periods. Now consider a generalized seizure. Brain activity can become extraordinarily intense and synchronized, but consciousness may be severely impaired or lost. More firing has not produced more awareness. In fact, excessive synchronization may reduce the brain's ability to support the differentiated patterns that ordinary consciousness appears to require. This has pushed researchers toward a different question. Not simply how active is the brain, but what kind of activity is occurring, how varied it is, and how effectively distant regions can influence one another. In the waking brain, information can spread through complex networks while remaining differentiated. Visual information has its own structure, sounds another, memories another, yet these streams can interact and become part of one coherent moment. During some unconscious states, communication becomes more restricted or stereotyped. One striking line of research uses transcranial magnetic stimulation to briefly perturb a small region of cortex, while EEG records how the response travels. In alert conscious people, the disturbance tends to produce a complex pattern spreading through multiple areas. During deep sleep or certain anesthetized states, the response can become simpler, more local, or more repetitive, as though the brain can still react but cannot sustain the same rich cascade of interactions. Researchers have developed measures of this complexity, although no single number can serve as a perfect consciousness detector, and interpreting such measurements in individual patients remains a serious scientific challenge. REM sleep makes the story even more interesting. Brain activity can resemble wakefulness in several respects, while the sleeper is disconnected from the immediate environment and may instead experience dreams. So, even an active, complex brain does not necessarily create ordinary waking consciousness. It may construct an internally generated world with entirely different rules. Severe brain injury provides another reminder. A patient can retain significant metabolic and electrical activity without showing reliable behavioral evidence of awareness, while in some rare cases hidden command following can later be detected, despite an absence of visible response. This means neither movement nor raw activity alone tells us exactly what is being experienced. The essential ingredient appears to involve organization, the capacity for many specialized systems to exchange information in a sufficiently flexible, differentiated, and coordinated way. But scientists still debate precisely what organization is necessary and why it should produce experience at all. That uncertainty matters. The brain is not a bulb whose brightness equals the amount of consciousness inside it. It is closer to an immense conversation. Millions of voices can be speaking and the room can be deafening. Yet noise alone does not create a meaningful dialogue. What seems to matter is which voices can communicate, how information travels between them, and whether the whole system can form a changing pattern rich enough to support a world. Your waking experience therefore depends on something more delicate than neural activity itself. The brain must not merely be alive with signals. Those signals must be arranged in the right kind of relationship. And somewhere inside that relationship, a relationship science can measure increasingly well but still cannot fully explain. Electrical activity stops being merely electrical activity and becomes the sight of a room, the sound of a voice, the knowledge that you are here, and the inexplicable fact that any of it feels like something from the inside. Scientists still cannot identify the exact moment an experience becomes conscious. A picture can enter your eyes before you can say with certainty that you have actually seen it. And somewhere inside those fractions of a second lies a boundary that neuroscience has been chasing for decades without being able to draw a single universally accepted line through it. Researchers can place an image on a screen for an extremely brief interval, immediately cover it with another pattern so that it becomes difficult to perceive, and then ask whether you saw the original object. By carefully adjusting visibility, they can create trials in which essentially the same physical stimulus sometimes enters awareness and sometimes does not. This gives scientists something extraordinarily valuable. They can compare brain activity when the outside world is nearly unchanged, but conscious experience differs. EEG studies reveal several candidate signals. One relatively early pattern, often called visual awareness negativity, tends to appear roughly a couple of 100 milliseconds after a visible stimulus and has remained one of the more consistent electrophysiological correlates of visual awareness across recent research. Later activity, especially a signal known as the P3B, was once frequently treated as a strong marker of consciousness, but experiments separating perception from the act of reporting it have complicated that interpretation. The late signal can largely disappear when people are not required to explicitly report what they saw, suggesting that part of it may reflect decision-making, memory, or preparing a response rather than consciousness itself. And this is where the apparently simple question, when did the image become conscious, becomes unexpectedly difficult. The first visual neurons respond rapidly after light reaches the eyes, but early processing alone clearly does not guarantee awareness, because the brain can analyze information that you later insist you never saw. Later, activity spreads and changes, but some of those later events may already be consequences of having seen the stimulus, rather than the event that created the seeing. Scientists therefore have to distinguish three things that can occur close together in time: neural processes preparing an experience, neural processes that are actually sufficient for the experience, and neural processes caused by the experience once it exists. The problem becomes even harder because the usual way to know whether you were conscious of something is to ask you. The moment you press a button or say, "Yes, I saw it," however, the brain must also remember the image, evaluate confidence, make a decision, and prepare the report. No report experiments try to remove some of those extra operations by inferring perception from eye movements or other physiological signs. But even these methods introduce assumptions about what counts as reliable evidence of experience. The timing itself may also depend on context. Experiments have found that expectation can shift when electrophysiological differences between seen and unseen stimuli emerge, and other studies associate subjective visual awareness with processing around roughly 200 milliseconds, rather than one fixed universal instant. This means there may not even be one identical timestamp for every type of conscious event. Recognizing a face, feeling pain, hearing a faint tone, noticing a thought, and becoming aware of an unexpected movement may rely on overlapping but not perfectly identical dynamics. Competing theories disagree about what must happen before information becomes conscious. Global neuronal workspace accounts emphasize widespread access and broadcasting of information, while integrated information theory places different emphasis on the intrinsic organization of neural activity. A major pre-registered adversarial study published in 2025 directly tested predictions from both approaches with fMRI, MEG, and intracranial recordings. The results supported parts of each framework, while also challenging important predictions from both, leaving no simple winner and no universally agreed neural border where unconscious processing becomes experience. So science can increasingly tell you what happens before you report seeing something, which neural patterns differ when perception becomes conscious, and how quickly those changes unfold. What it still cannot do is pause the brain at one universally accepted millisecond and say, with final certainty, "Here, this is the instant the darkness became seeing." The transition may be rapid, perhaps sometimes graded, and entangled with processes that precede and follow it. Your experience, however, hides all of this complexity. You do not normally encounter a face as a succession of neural stages. There is simply no face and then there is a face. No meaning and then meaning. Consciousness presents the finished arrival while concealing the border crossing that produced it. And somewhere inside that invisible transition lies one of neuroscience's most delicate unanswered questions. Not merely what the brain does when you see, but when neural processing becomes something, there is actually a you to see. Scientists can measure brain activity, but cannot directly measure what an experience feels like. Scientists can watch your brain respond while you stare at a brilliant red square, yet no instrument can look at the recording and directly experience the redness that you experience. That gap is easy to overlook because modern neuroscience can measure the brain with extraordinary sophistication. EEG can detect tiny electrical voltage changes produced by large populations of neurons near the scalp. MEG can record the faint magnetic fields associated with neural currents. Functional MRI can reveal changes in blood oxygenation related to activity across different brain regions. Electrodes placed directly inside the brain for medical reasons can record neural signals with far greater spatial and temporal precision, sometimes allowing researchers to identify activity linked to seeing a face, hearing a word, remembering a place, or making a decision. With enough data, scientists can even train algorithms to predict aspects of what a person is looking at, or which category of stimulus they are experiencing. None of that is trivial. It means private experience leaves observable physical footprints. But a footprint is not the foot that made it. Every measurement available to consciousness research records something public. Voltage, magnetic fields, blood flow, neuronal firing, eye movement, behavior, speech, or another physical response. The experience itself, the particular way red looks to you, the exact quality of a headache. the internal texture of embarrassment, the way your mother's voice feels when you recognize it, is accessible directly only from the first-person perspective of the organism having it. Neuroscience therefore works by linking subjective reports with objective measurements. Researchers present a stimulus, ask what you experienced, record what the nervous system was doing, repeat the procedure many times, and search for systematic relationships. This is how neural correlates of consciousness are studied. Scientists attempt to identify the minimal neural mechanisms associated with particular conscious experiences while separating them from attention, memory, motor responses, and other processes that accompany experience. The method is powerful, but it contains an unavoidable asymmetry. If you tell a researcher that a light looked faint, they can measure what your brain was doing when you gave that report. They can compare your brain activity with trials in which the light looked bright. They may eventually predict your answer before you speak, but the measurement still does not turn your sensation into something sitting on the laboratory table. This is why consciousness researchers continue debating how subjective and objective measures of awareness should be related. A person may discriminate a stimulus above chance while reporting very little awareness of it, or subjective confidence may change even when objective performance changes differently. Recent reviews emphasize that the relationship between these measures is informative, but not perfectly interchangeable. Pain offers an especially intuitive example. Doctors can measure nerve activity, observe facial expressions, monitor heart rate, study brain responses, and ask people to rate pain intensity. But there is no universal instrument that directly reads, "This pain feels exactly like this." Two people with similar injuries can report very different pain, while the same person can experience the same physical stimulus differently depending on expectation, attention, fear, context, and previous experience. The subjective report is not an annoying imperfection science is waiting to eliminate. In many experiments, it is part of the evidence for what the person experienced. Yet reports have limitations too. Language is coarse. Memory alters what can be described afterward. Some experiences resist precise description. Infants, many animals, and severely unresponsive patients cannot simply explain what their conscious world contains, forcing researchers to rely more heavily on behavior and physiological inference. No report paradigms attempt to infer conscious perception without requiring a verbal or button response, but scientists still have to validate those indirect indicators against situations where experience can be reported. This is why even remarkably advanced brain decoding should not be confused with reading subjective experience directly. If a system predicts that you are seeing a face, it has identified a physical pattern associated with face perception. It has not entered your perspective and discovered what that face feels like to you. You can never directly enter another person's conscious experience. You can know someone for 50 years, finish their sentences, recognize the meaning of a single glance, and still never experience even 1 second of the world exactly from inside their mind. This is not simply because people hide things from one another. It is built into the structure of conscious experience itself. Your own pain, colors, memories, thoughts, and emotions are available to you from a first-person perspective, while another person's inner life reaches you only through signs, words, expressions, gestures, actions, pauses, and everything else their body allows into the shared world. Contemporary consciousness research therefore begins from an unavoidable asymmetry. Your own experience is directly available to you, whereas another person's consciousness must be inferred from behavior or other observable evidence. Human beings have evolved an extraordinary collection of abilities for making those inferences. You notice where someone is looking, detect changes in tone, recognize fear in posture, infer intention from movement, and use context to estimate what another person knows or believes. Psychologists call a major part of this capacity theory of mind the ability to understand other people as beings with beliefs, desires, intentions, and perspectives that can differ from your own. This ability becomes especially revealing when another person believes something that you know is false. Suppose you watch someone place a key in a drawer and leave the room, and while they are gone, the key is moved to a box. You know where the key actually is, but to predict where that person will search when they return, you must temporarily separate reality as you know it from reality as they believe it to be. That mental separation is one of the foundations of social life. It lets you deceive, teach, comfort, negotiate, tell stories, understand misunderstandings, and recognize that another person can sincerely see a situation differently. Yet even a perfect prediction of another person's behavior would not give you their experience itself. If someone tells you that they are grieving, you may understand the reason, remember your own grief, recognize the expression on their face, and feel genuine empathy. But your empathy is still constructed inside your nervous system. You do not receive their grief as though it has been transferred from one consciousness to another. You build a model of it using what they reveal and what your own history allows you to imagine. Language narrows the distance enormously, but language also reveals the distance. The word pain can tell another person where something hurts, how intensely, whether it burns or throbs, and what caused it. Yet the word is not the sensation itself. The same is true of embarrassment, longing, loneliness, nostalgia, or the peculiar emotional weight attached to a childhood memory. You can describe the experience with extraordinary precision, while the listener receives a description rather than the original event. This is why misunderstandings can survive even between people who care deeply about each other. One person says, "I understand exactly how you feel," when what they actually possess is an increasingly sophisticated approximation constructed from communication, observation, memory, and imagination. And that approximation is still valuable. The inability to enter another mind does not make connection impossible. It makes connection an achievement. Every meaningful conversation is an attempt to carry something private across a boundary it cannot literally cross. Every metaphor is a bridge built because raw experience cannot be handed over. Every act of empathy begins with the recognition that there is another center of experience beside your own, one you can approach but never occupy. Science can study how humans reason about other minds and has identified distributed brain systems that support this remarkable social capacity, but understanding another mind remains fundamentally inferential rather than first-person access. And perhaps that is what makes another person both familiar and permanently mysterious. You can touch their hand, but not their sensation of the touch. You can hear their story, but not hear it through their memories. You can look into their eyes and know that an entire world is looking back, yet the world behind those eyes never becomes yours. Human closeness does not erase that distance. It is what we create across it. Two people may experience the same world more differently than either of them realizes. Two people can stand beneath the same light, look at the same object, agree on its name, and walk away without ever discovering that their experiences were not quite the same. You usually assume that perception is shared because shared behavior makes that assumption practical. You point toward a blue wall, another person calls it blue, and the agreement seems complete. But blue is a public label attached to private sensory processing, and even among people considered to have normal color vision, the biological machinery feeding that perception is not perfectly identical. Human color vision begins with cone photoreceptors, whose sensitivities depend partly on photopigments, and normal observers vary in these sensitivities and in other properties of the eye and visual system. Researchers studying color perception have documented substantial individual variation in color matching and judgments even among people who all fall within the range of normal trichromatic vision. The brain then has to solve an additional problem. The light reaching your eyes does not tell you directly which wavelengths belong to an object and which came from the illumination surrounding it. A white page under yellow evening light reflects very different light from the same page beneath a blue sky, yet you usually continue to experience it as approximately white. This ability, called color constancy, depends on the brain estimating properties of the illumination and separating them from properties of surfaces. Most of the time, Different observers make sufficiently similar assumptions that nobody notices anything unusual. But ambiguous images can expose the hidden interpretation. The famous photograph known as the dress became scientifically interesting precisely because identical pixels produce dramatically different experiences. Some observers reported blue and black, while others saw white and gold. Experiments found that differences in assumptions about the illumination contributed substantially to this disagreement. Nobody needed to be lying, inattentive, or using a different screen for the disagreement to occur. The visual system was trying to solve an uncertain lighting problem, and different brains arrived at different plausible answers. That example is unusually dramatic, but the broader principle reaches far beyond one photograph. Individual differences occur throughout color vision, from discrimination and matching to appearance and categorization, shaped by variations in sensory biology, adaptation, environment, and perceptual learning. Even age quietly changes the input. The optical properties of the eye change across the lifespan, and color discrimination can shift with age, yet the brain adapts so effectively that your own visual world usually continues feeling normal to you. This adaptation is important because perception is not a passive reading of physical measurements. The nervous system constantly calibrates itself against experience. What seems neutral, bright, loud, strong, familiar, or normal is partly judged relative to the sensory history of the observer. Two people can therefore receive slightly different biological signals and still learn to use the same words for them. The same principle extends beyond color, though each sense has its own mechanisms. One person may be unusually sensitive to a bitter compound that another barely notices. A sound at the edge of hearing can be obvious to one listener and absent to another. The same temperature can feel comfortable to one body and unpleasant to another, because physiology, adaptation, expectations, and recent exposure differ. Even when sensory organs deliver similar information, prior knowledge can alter interpretation. A barely recognizable shape may look meaningless to you until someone tells you what it is. Afterward, you may find it almost impossible to return to the original uncertainty because your brain now has a model capable of organizing the same visual evidence. This does not mean reality is whatever anyone wants it to be. The external world places powerful constraints on perception, and most of the time human sensory systems agree closely enough for us to navigate the same environments, build machines together, identify objects, and communicate reliably. The fascinating uncertainty exists inside that agreement. If you and another person both look at a sunset and call it orange, there is no everyday reason to ask whether the exact quality of that orange is identical in both experiences. Agreement in language can conceal differences in sensation because language was built to coordinate behavior, not to display one consciousness inside another. So you grow up surrounded by millions of people apparently inhabiting the same world, and in a practical sense, you are. The traffic light changes for everyone. The rain falls on everyone. The table remains where everyone expects it. Yet the world as experienced is filtered through eyes, ears, bodies, memories, adaptations, expectations, and nervous systems that have never been exactly duplicated. You share reality, but you encounter it through a biological perspective that has existed only once. And perhaps the surprising thing is not that two people sometimes see the same world differently. The greatest mystery is why anything feels like anything at all. If you strip consciousness down to its deepest question, you arrive at something surprisingly simple. Why is there an experience happening at all? Why is your brain not merely processing information silently in the dark? Science can explain more and more about what happens when you see something. Light enters your eyes. Cells in the retina respond. Signals travel into the brain. Different regions begin analyzing shapes, colors, movement, and identity. Information connects with memory. Your brain decides what the object is and how you should respond. Eventually, you can point toward it and describe what you are seeing. Similar explanations can be built for hearing, memory, attention, learning, decision-making, movement, and many other mental abilities. But in 1995, philosopher David Chalmers gave a famous name to a different question. He called it the hard problem of consciousness. The hard problem is not simply asking how the brain processes information. It asks why any of that processing is accompanied by a subjective experience. Why does seeing red have a particular quality? Why does pain actually hurt, rather than merely causing the body to pull away? Why does music sound like something from the inside? Why does fear feel different from sadness? Why is there a private point of view attached to all of this biological activity? Consider the difference carefully. Imagine that neuroscience eventually gives us a complete explanation of what happens when you drink coffee. Scientists identify the molecules that reach your tongue and nose. They explain how taste receptors respond. They trace the signals through your nervous system. They show which brain regions distinguish bitterness, warmth, smell, and texture. They explain which memories are activated and why the smell reminds you of a particular morning years ago. They even predict the exact moment when you will swallow and the sentence you are about to say, "That coffee tastes strong." That would be an extraordinary scientific achievement. It would explain how the system works in remarkable detail. But the hard problem asks whether one question would still remain. Why does all of that processing come with the actual taste of coffee? Why is there a private bitterness, warmth, aroma, and familiarity that you experience from the inside? Why is there not simply a complicated nervous system detecting chemicals, producing behavior, and reporting information without anything being felt? This is the distinction Chalmers wanted to emphasize. Science can describe what a system does. It can explain how information is processed, stored, compared, and used. But explaining what the brain does not automatically answer why those processes should have an inequality at all. Not everyone agrees that this requires a completely separate kind of explanation. Some philosophers and scientists argue that once we fully understand perception, memory, attention, self-monitoring, language, decision-making, and the brain's ability to represent its own activity, the apparent mystery may disappear. According to this view, what we call the hard problem may partly come from the way the brain thinks and talks about its own internal processes. Others disagree. They argue that subjective experience is a genuine feature of reality that cannot be fully captured merely by explaining what the brain does from the outside. These disagreements are not small details surrounding an otherwise solved problem. They sit near the center of modern consciousness research. Several major scientific theories attempt to explain which patterns of brain activity are especially important for consciousness. One influential idea, known as global neuronal workspace theory, suggests that information becomes conscious when it becomes widely available across many parts of the brain, allowing different systems to use it for reasoning, memory, decision-making, and action. Another influential approach, known as integrated information theory, focuses more strongly on the way information is organized and connected within a system. Scientists have been testing these theories against real brain data. In 2025, a major study published in the journal Nature Directly compared important predictions from these two approaches using several different methods for measuring brain activity. Some predictions from both theories received support, while other important predictions were challenged. The result did not produce one final winner. Instead, it showed how difficult the problem remains. But even imagine that one theory eventually succeeds far better than all the others. Suppose scientists discover the exact pattern of brain activity required whenever you experience the color red. They can predict when the experience will appear. They can interrupt the pattern and make the experience disappear. They can restore it. Perhaps they can even determine which shade of red you are looking at before you say anything. That would tell us an enormous amount about the neural basis of consciousness. And still, one question might remain: why should that pattern feel red? Why should another pattern feel like physical pain? Why should another feel like loneliness? Why should another produce the sound of music inside experience, rather than simply controlling the behavior of a biological machine? This is where ordinary scientific language begins to struggle. Most scientific explanations move from one publicly observable fact to another. We explain temperature through the movement of particles. We explain inheritance through biological processes involving genes and deoxyribonucleic acid. We explain planetary motion through gravity and the laws of motion. In each case, both the thing being explained and the explanation itself can be described from an outside point of view. Conscious experience introduces something unusual. Your brain can be observed from outside. Your experience exists from inside. The connection between the two is undeniable. Damage the brain and experience can change. Alter brain chemistry and mood or perception can change. Place the brain under general anesthesia and ordinary conscious experience can disappear. Stimulate certain brain regions and specific sensations, memories or perceptions may appear. So consciousness is deeply connected to what the physical brain does, but knowing that two things are connected is not necessarily the same as explaining why one of them has an inner feeling, and that is why consciousness remains one of the deepest scientific and philosophical mysteries we know. This does not mean consciousness is supernatural. It does not prove that science will never explain it. It simply means that, at present, there is no broadly accepted explanation for why physical activity in a nervous system should produce subjective experience. Maybe future neuroscience will discover a principle we are currently missing. Maybe the problem will become easier once we learn to describe the brain in a completely different way. Maybe scientists will eventually discover that the question itself contains a mistaken assumption. Or perhaps consciousness will force us to change something fundamental about what we believe a scientific explanation must accomplish. For now, however, the mystery remains directly in front of you. You can doubt your memories. You can lose attention. You can fall asleep. You can wake up confused. You can examine another animal and wonder whether it is conscious. You can scan a human brain and watch patterns of neural activity changing in real time. But underneath every one of those questions lies something even more basic. There is something it feels like for any of this to happen. Right now, these words are not merely being processed by your nervous system. They exist in your experience. Perhaps you hear them as an inner voice. Perhaps they create images. Perhaps they produce curiosity, calm, confusion, or nothing especially dramatic. But even that quiet sense of simply being here has a subjective quality. Matter has somehow organized itself into a nervous system capable of studying stars, atoms, evolution, memory, and even its own brain. And somewhere inside that organization, something extraordinary happens. Physical processes become more than events that can be observed from the outside. They become an experience occurring from within. We know that it happens. We can increasingly measure the conditions under which it happens. We can sometimes remove it and watch it return, but we still do not fully understand why it feels like anything at all. And perhaps that is the deepest mystery. Hidden inside the most ordinary fact of your life, you are not merely alive, and you are not merely processing information. Somehow being you feels like something